We started having sound. Double check if you have sound as well. Test.
Yeah, it's
Okay,
working.
so we have
Thank you very
sound.
much.
It's starting to work. Stuff is happening. So we just need to get the screen there. Let's wait one more minute because this officially starts in 1 minute. Ooh. It's not connected? Okay, so let's figure it out. Starting with, oh, I know why it's not connected. It is. It should be connected now. Okay, at least my computer recognized it, so let's wait. Cool, it's there. But it's connected here. Ooh. Turning it off. And on. And the computer just recognized it, so it changed into the mode. It's showing up here. Yeah, that's an issue. Pro HDMI. Okay, in the meanwhile, we're gonna stall, we're gonna let some people come in because this first session is, oh, there it is. Woohoo! Okay, so, that part on the top, there's gonna be some subtitles there. If there's a word there that it seems weird, it's probably not the word I said. This is trained by AI. Let's hope it's working. See, 1,000 years. I don't think that's what I was saying, but we'll figure it out. Doesn't matter for now. We're ready to start. So let me just connect my keynote. Let's go there. Da-da-da. Looking for computer. Cool. Okay, while we're starting, we are going to have this first 10 minutes, which is just basically an introduction and a disclaimer to what's changing this year, because there are some differences. Who here has attended JNation in the past? Okay, so some of you might be wondering, what the heck is happening here? It used to be 50-minute sessions. All the other tracks on the conference have 50 minutes, and this one has 40, 25. There's something weird here. And this is why we're here to explain you and what changed this year. First of all, let us just introduce ourselves real quick.
Yeah, this will be super quick. My name is André Simões. I'm almost 40 years old, 15 years of JavaScript suffering. I'm a front-end engineer, and I like to be updated with the last news about the JavaScript world. Yeah, go on.
Okay, and like Andre, I'm also part of the organization here from JNation. I joined this year, so this is my first time here. This is crazy. I'm having so much fun. It's stressful, but it's being fun. I'm Daniel Afonso. I'm working as a developer advocate at OLX. I'm part of the DX team for Solid.js. We're going to have some Solid talks today here. Who here has heard about Solid? Okay, cool. Some cool people here. We're going to get more fun in a bit. But yeah, that's it about us. If you want to find us on any social media, this is basically our handles. And let's keep the party going.
Okay, so for the last few years, I was helping organizing JNation, specifically this track, JavaScript web track, and Daniel was speaking here. This year will be a bit different. He's helping us also with the organization. We talked a lot about how we could improve the JavaScript track. Some conferences, JavaScript conferences around the globe are doing shorter sessions. 20-25 minutes, and we'll try that this year. So with that, we'll have more sessions and more speakers. I hope you enjoy.
Okay, and with this in mind, what Andre just said, it was clear that our way to go was to try something new. So we're bringing some of the most impressive speakers around the JavaScript and the web from the world. They are really, really good. And I would like you, first of all, to start measuring the energy of this room, to do like a huge ovation and like scream and go wild to just welcome our speakers. So we're going to have Tejas, we're going to have Attila, we're going to have myself, we're going to have Marta, Mateus, Elian, Ayub, Max, and Zach. Come on, make some noise for them. And these speakers are going to speak about crazy stuff. There's going to be a bunch of content here. We have stuff from JavaScript, TypeScript, native apps, Core Web Vitals, Solid, React, Quick. You can imagine it, it's going to be here. So let's just take a look at the schedule real quick.
today we will have 9 talks and 1 panel discussion. The opening and closing keynotes will be 40-minute sessions, and the other sessions will be 25 minutes. The schedule will be a bit challenging, so we kindly ask you to be on time, because we will try to start and to end at time. Also, something very important, this year there will be no official Q&A at the end of the talks, but if you have any questions, feel free to reach out to the speakers. Okay? Thank you very much.
Also, in the afternoon, we're going to have a discussion panel called The Future of JS Frameworks, where 4 of our speakers will talk about what's going to happen in the future, what should we expect. There's going to be some surprises during and after this panel. I'm not going to spoil the fun for you yet, but it might be related to our next speaker. And okay, I think it's enough time of us speaking here, because now we are getting ready for the real fun. Let me check the schedule. We're going to probably start 5 minutes early. Are you okay with that, Tejas? It's okay. So, I'm getting ready to introduce our next speaker. So, I struggled a lot figuring out, okay, how am I going to introduce him? Because this person probably is one that taught me the most about doing public speaking, and is one of the people that allowed me to be here today and made me grow. So I'm a bit biased to introduce him, because he's a really good friend. So our next speaker, Tejas, is working as a DevRel engineer at DataStax, and he's here to tell you all that you are an AI engineer. So I want you to make some noise, because there's going to be a lot of heckle here, and I want everyone to hear what's happening. So give it up for Tejas Kumar. For a bit.
It'll be.
Okay, just let him plug in stuff.
That's cool. I see familiar faces here in the audience.
So many cool people, right?
I like that she's waiting to start the timer here.
Yes.
Okay. Slides? Do I have slides? Are they?
See? Double
they
check.
gonna show?
Are we getting input there? There
There
is.
we
Okay,
go.
so I'm gonna leave you and have fun.
Hey, thank you, thank you. Let's give it up for Daniel and Andres, everybody. Excellent. Well, hey, hi, I'm Tejas. Nice to meet you. I often introduce myself by saying I'm Tejas. That's pronounced like contagious. And like 9 out of 10 times, I'm not contagious. Today, I actually do have almost a common cold, so I may be contagious. Keep your distance, and whoever gets this microphone next, I'm sorry. But it's nothing serious. It's just a common cold, so I think we'll be fine. Over the course of my career, I've been able to work either as a consultant or as a teammate at some of the greatest tech companies in the world. And it's been an absolute joy. At some point, I hope my clicker doesn't work. Also, this is an AI talk, also a JavaScript like UI talk. And just before going on stage, Elian sitting over there, sent me a picture that said ChatGPT is having an incident right now, so none of this may work. Anyway, I've had the privilege of working at some of the, I love these companies. They're all great. We've worked together in some way, shape, or form, and it has really helped shape a lot of my career, and I bring some of that to you today, okay? The clicker really doesn't want to work, unfortunately, so I'll just stand here. I'm a developer experience engineer or developer relations engineer at DataStax. DataStax is a company that makes a database but also wants to be an AI company, and it's sort of my job to help them do that. But we're not here to talk about any of that today. We're here to talk about the idea that you are an AI engineer. That's sort of the title of the talk, and it may be a little bit pointed, but there's a lot to be said for AI engineering, and the whole purpose of this, let me start by telling you about the motivation. I want this to be accessible to you. If you feel imposter syndrome around AI, I want to remove that. I want you to be able to work in this space. Mainly because it's a new space and there's a lot of innovation, but also, if we're just being real for a minute, company valuations are the highest in the AI space. Salaries are the highest in the AI space. And I want you to live your best life, okay? I want this to be accessible to you. So with that, let's get started talking about this. And we'll have some demos given if we have enough time. So let's start by talking about AI engineering. What is an AI engineer? In coming to this conference, even before coming here, I asked a ton of people, what is an AI engineer, and do you think you could be one? Right? If I ask you, what is an AI engineer, and do you think you could be one? The answers I got were very surprising. People were going, oh, I'm not, I couldn't be that. And I say, why? And they say, well, because I don't know anything about linear algebra. I didn't go to university and like flip matrices. I'm not good at data science. I don't know how to train a machine learning model. And I'm here to tell you today that that has probably nothing to do with AI engineering. We believe this lie, we believe this, it's maybe not a lie, that's too strong of a word, but we have this misconception that machine learning and AI and data science are the same or very close, but they're really not. Okay, and this is what I'm here to tell you today. I'm here to define this for you in a way that makes it accessible to you. And some will be like, oh, you're minimizing our work, whatever. Those are the same people who will tell you HTML is not a programming language, you know? It's not technically, but it is because you can build programs with it. So this is where we are today. Okay, so let's talk about AI engineers. What is an AI engineer if it's not just a glorified machine learning engineer or a data scientist? To understand this, let's not take my word for it. You may debate whether I'm qualified or not to like coin this term. Let's lean on people who are smarter and better than me in many ways. And by this I'm talking about the great Sean Wang. Anyone know Sean Wang? That's like one person. Sean Wang, aka Swix, is a former finance person who turned into a web engineer and now is a leader in the AI space. He's the founder and CEO of a company called Small AI, and also runs a really powerful, influential podcast / newsletter in the AI space called Latent Space. Sean is like one of the global leaders in the AI space, and he, on the foundational article that he wrote titled The Rise of the AI Engineer, defines it this way. He defines AI engineering as this specific diagram here, which is you've got machine learning research, machine learning engineering before the API, and the AI engineer and the full stack engineer after the API. So this really separates machine learning and AI engineering from each other and gives you a nice basis for discussion, right? Further, underneath the diagram, what you see is a quote from the great Andrej Karpathy. Andrej Karpathy is the former director of AI at Tesla, so self-driving, he's the guy behind it, and also the director of engineering or director of AI at OpenAI, formerly, right? So like the leader in the space, says this. What does he say? He says in numbers, there's probably going to be significantly more AI engineers than there are machine learning engineers because of this, because it's behind the API, okay? Or in front of the API, depending on how you see it. He says one can be quite successful in this role. What is that? Without ever training anything. So if I ask you again, do you think you could be an AI engineer? You don't need a machine learning research background. You don't need data science as a background. The application of AI to solve problems is what makes an AI engineer, according to all of this data. Okay, so what is engineering? Engineering is applying technology to solve problems. That is literally the definition. You apply technology to solve problems. What is AI engineering? You apply AI technology to solve problems. Right, that's the definition. So it could be, if you're, this is the JavaScript track, if you're a JavaScript developer, it could be using AI. So you make a fetch request to ChatGPT and get some generated text and then use it to solve a problem. That could make you an AI engineer. Based on this is not me, this is Sean and Andre, okay? So let me ask you again, I see people laughing over there. Let me ask you again, do you think you could maybe, okay, one final quote. This is something Sean says in the article. He says, this will likely be the highest demand engineering job of the decade. And we sort of see that, again, with company valuations and with the salaries. Some people are making like upwards of $600,000 a year just being an AI engineer in this very like undefined title. Okay, we've talked about AI engineering. Let's talk about AI. This term, unfortunately, is abused these days, right? Because it can mean many, many things. In fact, if you put AI somewhere in your slide deck, you'll probably raise a bigger funding round, unfortunately. AI is a term that now is just, you've seen the Google keynotes with Sundar going AI, 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 AI. What is it, 121 times he says AI. It's this word that is used so much and leads to so many good things / hype cycles that it is abused. Let's clarify this a little bit. Because there's different types of AI. AI is not new. AI goes back to the year 1906, right? The beginning of the 20th century. A man named Andrei Markov created a statistical model called the Markov chain, which is the basis for natural language processing, which is the basis for what is called predictive AI. That's one of the types of AI here. What is predictive AI? If you have your phone, your smartphone, that was invented in 2007 with the iPhone, right? Debatably. If you have a smartphone and just above your keyboard you have these little suggestions for the next word, and you've played the game, right, where you just tap the suggestion and come up with some gibberish text, that is predictive AI. That was 2007. Right? Markov models from 1906, like this is not new. There's also rule-based AI, which is if you're playing Pac-Man, Pac-Man eats the little berries and the ghosts turn blue and avoid Pac-Man. That's AI, that's rule-based. It's literally artificial intelligence. It's just, it follows predetermined rules, or in the case of Markov chains or predictive models, it follows statistical models. Those are all AI. What we're talking about these days with the advent of ChatGPT and so forth, and the Transformers architecture, a paper published by Google, is generative AI. And so these algorithms are optimized to produce novel things given previous inputs. So you say like, hey, here's a combination of data, generate something for me, and what it generates is typically novel, right? This is closer to how also our brains work to some degree. So the hype is not around rule-based AI or predictive AI, which goes back centuries, or at least 1 century. It is generative AI, or sometimes called Gen AI. Clear so far? Great. Generative AI. So why is generative AI so hyped? Well, because it brings novelty. Imagine building a recommendation engine. You run Amazon.com, and you can show people, hey, here's products that you love. We know you love this because we have enough data on you, unfortunately, to sell you these things, right? It's generative. It leads to highly popular business outcomes. However, Gen AI has some problems. And remember, we defined AI engineering as solving problems with the application of technology using AI, right? Well, Gen AI has some problems of its own. Some of you may have noticed this. For example, it hallucinates. It is often confidently wrong. Anyone experience it? Like Google just released the, it hurts me to even say this, Google released a feature called AI Overviews. I don't know if you've had the misfortune of using this, but gosh, like somebody asked Google, hey, how many cigarettes is it appropriate for a woman to smoke when she's pregnant? And Google's AI overview, I'm not even making this up, said 1 to 2 cigarettes per day. Okay? Confidently wrong, much like some speakers at conferences. I'm talking about myself, I don't mean this about anyone. Anyway, confidently wrong. And so that's one issue. It hallucinates. They see things that is not there. Number 2, every large language model that powers an AI application has a finite context length. Even something like Google's Gemini, right, multimodal, has a 2 million token context length. For those who don't quite understand tokens, it's roughly equivalent to 1 token equals 1 English word, roughly. So, words have arbitrary lengths, and so it's not 1-to-1, but it's close enough. So 2 million words is sort of the top level of context, which, if you think about it, isn't that much, right? It's sort of like a long book. You can't have your entire lifespan in such a context window and have an assistant like Jarvis. You can't do that. It's a limitation. Number 3, knowledge cutoff. So GPT 3.5, for example, has a knowledge cutoff, I believe, in still 2023. GPT 4.0, of course, is May 2024, but there's always like a date past which the AI models don't know stuff, or the large language models don't know stuff. So these are the big problems with Gen AI today. I'm here to show you how to solve those and make it more accessible to you. Okay? We've got some demos. I don't know how much time I have, so we may be over, we may be under. There's an emerging technique that solves all of these problems and unlocks Gen AI for real-time use cases. So an example, right? Imagine your target, and it's raining outside, and you want to, the timer's working, Daniel, it's okay. It's working, it's good. So imagine your target, it's raining outside, and people are going to Target.com for some reason. You want to show them umbrellas based on the current weather, you know? Business. how can you do that? How can you give real-time information to a large language model that has a knowledge cutoff in 2023? There's a technique called RAG. Anyone heard of RAG? Okay, like 4. That's cool, that's why we're here. RAG stands for Retrieval Augmented Generation. So the G in Gen AI is generation, it generates text. You retrieve data, so R, you retrieve data, you augment, you change the generated output. RAG, Retrieval Augmented Generation. In basic terms, you just get data from somewhere that's current, like get me the weather right now, give that as context to something like GPT-3 or ChatGPT. Hey, ChatGPT, the weather right now is it's raining. Okay, should they buy an umbrella? You know, that's basically it. You just get data and you use it to augment generated output, RAG. RAG has some components. You obviously need data. You need like the weather right now. You need an embeddings model. Okay, what is an embeddings model? Embeddings models, they take text, so natural language like English, and each word is given a numerical representation in high-dimensional space. What is dimensional space? The human mind can comprehend like 3 dimensions, 4 if you account for time, right? So we have an x-axis, we have a y-axis. This is 2-dimension. Maps are 2-dimensional coordinate systems are 2-dimensional vectors. So x-axis, y-axis. Depth is the z-axis, so we have 3 dimensions. Whoa. High-dimensional space goes up to like 1,500 dimensions. What does that even? I can't show you that. But embeddings models take words and put them like in a 1,000 plus dimensional space, such that words like food and hot dog and cake land in the same location, and words like JavaScript and Python land in another location. So it's just assigning spatial meaning to words. That's what an embeddings model does. And finally, you need a vector store. And a vector store can do similarity searches based on these numbers. So if you search for food, a vector store will find you records about adjacent topics like hot dogs. If you search for code, it will find you, Visual Studio Code or Python. So it's just proximity search. These 3 components make up RAG. I'd like to show you a quick demo of this today. Using a product, so where I work, DataStax, we make a database, we make a vector database, so that for RAG. But we also make we recently acquired a company called LangFlow. It's like LangChain, but it's a visual builder. And I don't want you to use it per se, but I want to show you the flow of how this stuff works, okay? And I think LangFlow is a really great tool to do that. So let me come over here to my laptop, and I will run LangFlow. So we'll just LangFlow run. And so while that's running, let me come over to my Astra database. And I've got a database here called JNation. That's LangFlow. So I've got a database here called JNation. I'm going to create a collection, and a collection is just a table. I'll call it stuff. I don't really know. And I'll say I want it to have 1536 dimensions. And again, we talked about dimensions. And a similarity metric is like, how do you do the search? So I created this collection called stuff. Let me show you LangFlow. And what I'm going to do is I'm going to make a new project called a vector store RAG app. That's literally what we just talked about. And I want to show you the flow of data, because this is how RAG works. And I think it's really cool that they visualize it. So you start with a chat input, right? And an embeddings model. We just talked about an embeddings model. And you connect them to some type of vector database search. In this case, we're using Astra. That's my company's product. But you can use whatever you want. And you give it a token. So we'll say the Astra DB API key. And these are just environment variables. The collection name we just made is called stuff. And the input value, you see this line here, it sort of comes from the chat input, okay? And the embedding model comes from here. So then we break the user input into some chunks, just so the text has some overlap with itself. And we generate a prompt. You may have heard of prompt engineering. This is the prompt. It says, given the context above, this comes from the vector search, answer the question as best as possible. And this is the user input. So we get this prompt. We pass it to a large language, model, in this case GPT 3.5 Turbo, with an OpenAI API key, and the chat output. That's really it. And what I'll do is I'll come here and maybe make it like stream the output, because I like the snappy UX. Okay, so now if I play this, right, it should give me a little chat UI. So I go to the playground, and it does that. But I could be like, so let's illustrate a problem, because Nike, anyone familiar with Nike? Anyone wearing Nike today? No? Nike, cool, man. Nike just released, literally, like recently, a Python framework for data pipelines. Nobody knows about this. It's brand new. ChatGPT for sure doesn't know about this. So it's called this. It's called Cohesio. And it's cool. It's a little it's a Python framework for data pipelines, right? So I will be like, tell me about the Python framework Cohesio. I believe the spelling is right. That's true. And of course, it's like, dude, my knowledge cutoff this doesn't exist. Or at least it should say that. Yeah, there's no known Python framework called Cohesio. But let's fix this with RAG. And this is exactly solving the problem with RAG. So if I come here, there's also an ingestion pipeline here. Check this out. So I can either from a file or some source, break it into chunks, use an embeddings model to insert the data into my AstraDB. So I'll use the API key, the same endpoint, collection name is stuff, and instead of a file, I'll just read from the internet. So I'll go here and add data as a URL, and I'll just paste this GitHub repo. Boom. And of course, you draw a line. This is very important. That's it. So now I'll choose the right embeddings model, and I'll insert this GitHub page into my database. And it's just going to like read the GitHub page. As you can see, it's inserting some records into my database. And you can do this as code. I just want to show you the diagram because I think we can reason about it nicely. And if I go look in my database, reload the page, we should maybe add some like WebSockets or something. Let's reload the page. And we have some, come on, we have some records, right? So we have, this is just a bunch of stuff from the GitHub page. Okay, what does that look like in practice? Well, if we come here, go back to our read pipeline, to the chat playground, and I'll just send exactly the same prompt. Tell me about the Python framework Cohesio. Let's see now RAG in action, because it's going to search that database for similarity, and Cohesio is a Python framework. Suddenly it just knows stuff. And it's still GenAI, but with more extended knowledge through a RAG pipeline. Is that clear? This is how you solve the problem of hallucinations, finite context, and knowledge cutoff. And you can look here on the left. This is all the stuff we actually got from the database after that ingestion pipeline. So this is something that, where I work, we're committed to making this very easy and accessible for people because it can and does help you build more powerful things using GenAI. Okay, that's RAG, or Retrieval Augmented Generation, in a nutshell. Let's go back to the presentation. And while that's cool, while GenAI can solve some problems, I'd like to take a few minutes and talk to you about going beyond just text. Okay, I'm talking to you about not just GenAI, but GenUI. Okay, because like you remember we talked about the problems with GenAI, right? We talked about these three. Turns out there's a fourth one if you consider like pleasant user experience on the web. The fourth one is that LLMs, they produce mostly text. And sure, ChatGPT can generate images. With Sora, you can generate videos. But ultimately, it's mostly text. And that kind of sucks, if you ask me. What if we could, we're web developers. This is the JavaScript track. This is the UI track, right? I want to make like nice UI instead of just text. How can we do this? We can do this with GenUI. And I'd like to show you a little demo. What we're going to be using is the Vercel AI SDK. I used to work at Vercel. I don't do this anymore, but it's actually really great engineering, I must say. And as a former employee, like I can't. I should maybe have bad things to say, but it's actually really good. It's very surprising. But anyway, cut that out of the recording. I don't want to say it's surprising. So anyway, let me show you. So we have a project called GenUI, and NPX Next Dev. It's a Next.js app. And I know how you Astro people feel about this, but let's just roll with it for now. So this is a chat bot, and what I have is a little UI that says, ask me anything. Okay, so show me movies about future with AI. And I'm going to ask, and it just fails. You know why? Because nothing's implemented. So let's look at the code and build this together in like 20 minutes. Okay, so what do we have here? We have a layout. Anyone use Next.js here? This should be familiar to you if you use Next.js. We have a layout. We wrap our layout in AI. Okay, what is AI? AI is a call to create AI, where we have actions. This action, continue conversation, does nothing. And we have AI state, UI state, okay? What else do we have? We have a page, and we have messages, as you can see. Messages, let's reload this. Messages is this whole area up here, and the chat form is the chat form. And if you want to look at the code, messages just maps over conversations and shows you messages. And the chat form is exactly what you think. It's just a form that when you submit the form, we set the conversation to what the user input. We call continue conversation to get some output from the large language model. And then we set the conversation, which is just a big array of messages, to the new message from the LLM. So we're just like adding messages to an array. That's what we're doing, okay? So this clearly doesn't work, and it doesn't work because our action is undefined, okay? So we'll fill this in together and understand what's happening. So this is an async function. As you can see from the chat form, we call it with the input from the user. So let's just fill it in here. It's an async function that returns, the, sure. Instead of, let's actually import nano ID to give it a unique ID. Instead of AI, it returns a message from the assistant, and its display value is sort of undefined here. So we need to define it. So we'll get some UI. So we'll say result is, and we get a function called stream UI. Okay? And stream UI gets some stuff. Most importantly, it needs a model. So we'll use OpenAI and hope that it's not having an incident that affects us. So we'll import OpenAI from AI SDK/OpenAI. And we'll use GPT 3.5 Turbo. Then you need some more stuff. You need a list of messages. We can get the history by calling a function called getMutableUIState, like this. And so the history now of messages is whatever's in here in history.get. And of course, we get the user input. So we'll do this. And instead of display, it's content. So this is just the input from the user, you know? And that's it. And so now, if we get the result, we can do result.value. Okay? Very simple. What are you complaining about? String. Okay, cool. This should be more than enough to just get a chat response. Let's take a look. So we come back here. Show me movies about the future of AI. Okay, cool. It kind of works. We're getting text, but it kind of sucks because it's a list, but it's not like, there's no margin between the list items. So let's fix it. So we're getting back here text, right? So what we can do is we can format the text a little bit. We can say for text, we get some stuff. We get, are you done? And we get the content. And what we can do here is return. Actually, if we're done, then we call history.done with history.get and the assistance message. And finally, we return content, which is just a string. But we can also do something cool, like we can wrap this whole thing in Markdown. Because guess what? We can return React components here. And so let's import Markdown from React Markdown. And we can even do a custom renderer. So we can say components, well, for P elements, you get children, and we can space them out a little bit. So we can say P class, we can use Tailwind CSS, why not? And do children, look at that. And just like that, we have a little bit richer text. So now if we ask, we have at least some space between them, wow, right? But why stop here with generative UI when we can return React components? You understand? So instead of this, what if we can add some tools? And I'll finish with this, tools. And we define a tool called getMovies. And we search our Astra database with similarity search. We search all of IMDb from my vector store and get similar movies. So we'll do getMovies. And the tool gets a description, thank you, Copilot, right, by a prompt. And we get parameters. This needs to be a Zod schema. If anyone uses Zod, it's just a way to type objects. So we'll import Z from Zod. And parameters is a Zod object with a prompt that's a string. And we can even describe it if we want. Come on, Copilot, do your thing. Whoa, perfect. And finally, we need a function called generate. It's an async function that is type safe. That gets, if I have a typo here, you see that? It's supposed to be product. It just gets it from the schema, okay? And so now what we can do is get data from my database. So const db, or actually let's do client. And we'll do the same thing, data API client from Astra. We just talked about that. Process.env ds API key. and that's defined. Const db is client.db, and we just get our DS, that's DataStax API endpoint. It's defined. And then we just say data is we'll await db.collection. We have a collection called IMDb OpenAI, and we'll find movies that are similar to the prompt. So we'll be like, find where, vectorize. So we convert the prompt into a vector, and we turn it into an array. Okay? We get the data. Now what we can do with this data from our vector database, we're doing RAG here, we can return a React component. Let's do it. So we'll return div. Actually, let's do a UL. Let's be semantic about this. And look at that. Fantastic. Data.map. Movie is any. Fair. We'll do key is movie.id. And here we can go absolutely nuts. We can do whatever we want. We can, for example, let's make it a flex box. Class name flex, items center. This is Tailwind, by the way, and you can see why it's actually giving me a Tailwind. I can write this style so fast. Okay, and here I could do a, look at this. I can do an IMG. I can even do something like width is 100, height is 150. We can maybe do a limit of 8 so we don't get too many records. And we can show the movie title here. So maybe an H2. Movie.series title. Of course, this is all, these are fields on my database, so I could do poster, link, and just kind of do this, okay? This can work, but let's make it even better. Let's do like class name rounded, give it a shadow, you know? Let's even go here and be like, look, let's transition everything, so animations, and when you hover, then we like raise it, you know? Just like go absolutely bananas, okay. This seems to be okay. I'm not seeing any issues. So that's kind of what we did. We got a search result from a vector database and rendered a bunch of images. Let's see if that actually works. So I'll run the same prompt and show me movies about the future of AI. And please don't disappoint. Oof, look at that. And it like, ooh, you see that? Incredible. Wow. We went from this to this. Unbelievable. Now we could do even better because like this doesn't do anything. It's just sort of links. Let's fix it by making them anchors. So we'll just wrap this in href is imdb. Oh, wow, Copilot, you were so cool. Instead of this, we'll do like find q equals movie.series title, and we'll close this here. This, and let's also do a target. I'm just, at this point, I'm just hacking because I have time. Okay, this looks actually pretty nice. Save. So now it's a link. Let's try this again. But what you'll notice is this, it's like, it's stuck for a while, right? Do the links work? Fantastic. Come on, IMDb. Oof, brilliant. Okay, that's great. This is a great movie, by the way. Okay, so the final thing is we want pleasant user experience, right? And this kind of sucks. Like, look at this. Show me movies about. If I click ask, there's what is that? Yuck. I don't like that. So using generator syntax, we could do even better. So instead of this async arrow function, we could do a generator function. Ooh, okay. And now because it's a generator, we can yield whenever we want. So we could be like here, yield. Starting, and this can also be a React component, so I see the dots in your head connect. We can then be like searching Astra vector store, right? And then finally it will return. So we give this beautiful feedback to a user, and that's why we're here. It's the web track. We care about user experience, okay? This can also be, as I mentioned, a React component. Okay, let's maybe not have the doom and gloom future of AI. Let's show me movies about happy comic book things. I don't know. Batman. I don't know. This is probably going to go wrong, but let's see. And so now you have searching. Oof, you have this beautiful feedback, and indeed it is about Batman. Holy smokes. So this, let's take a moment and appreciate how it started and how it's going. Okay, we started with this. Yuck. We then, okay, cool. We have some spacing, but why? Why text? Why not rich web UI with animations, with components, with links, etc. I want to wrap up by saying, look, this is an example of a chat bot, but honestly, I think chatbots suck. If you're building a chatbot with Gen AI or even Gen UI, you've missed something. Because I use this for an illustrative purpose to show you, like, we started here, we're going to go here. But imagine you have an e-commerce store. You want to use Gen AI, Gen UI, to get similarity of products that people have bought, and you want to build a recommendation engine. Maybe it's not an e-commerce store. Maybe it's a Visual Studio Code extension store. Here's some extensions you may like that are open source, because this is not for profit, right? Instead of a chatbot, what if you had a section of your UI, like a row of icons, and these were generated using Gen UI? You can do that. Let's wrap up. I do want to also basically give you some more context, because what I just showed is taken to another level by the great work of a friend of mine named Evan Bacon. Evan works over at the Expo team. Expo and React. Expo is like a framework for React Native. And what I just showed you, Evan has built to do on all platforms at the same time with one code base. So Android, iOS, desktop, web. That Gen UI piece comes to all platforms. And with iOS, it's like native iOS components. It's not even like web component. It's absolutely nuts. So if you want to watch his talk, I highly recommend it. Let's talk about the future. That's where we are with AI. We started with me asking you, are you an AI engineer? And you're going like, oh, I don't know, machine learning. I'm not a data scientist. Well, you don't need to be. AI engineering is a whole new field with things like RAG, vector stores, Gen UI. How do we process stream responses to give users value? This is AI engineering. This is the web track. This is the JavaScript track. Let me ask you again, could you be an AI engineer? I hope I've made this more accessible to you today, okay? Let's talk a little bit about the future. That's where we are today. Where are we going? There's a lot of talk about two things in particular I want to focus on. One is agents, AI agent workflows. OpenAI calls us the assistants, as Zach told me yesterday. But ChatGPT, large language models are cool. But at the current point in time, they're really great at like generating you an email that you can copy and paste to your team. They cannot create an email and then send it for you on your behalf. Okay? This is where we're going, though. Like a lot of us, I'm working on exactly this. So I run a podcast. Each episode is very long. It's like 2 hours. And we ship episodes twice a week, every Monday, every Thursday. And we can do this because my podcast is run by a team of AI agents. They literally like do the work. Somebody schedules something with cal.com, and immediately an agent is like, who are you? Researches them, creates a discussion outline, sends it to both of us. We read it, we go, right? AI agents that can execute tasks on behalf of users is where we're going. And there's plenty of ways to do that. Unfortunately, there's 5 minutes left. I'd love to give you a whole lecture on that, maybe sometime. That's topic number one for the future. Topic number two for the future is small, specialized language models. So GPT-4 has many, many billion parameters. And by the way, a parameter, when you hear about large language models, think about it as a little dial that you can turn. If you've seen like a mixing board for sound engineers, you know, there's all these like knobs, and they turn like bass and treble and volume and stuff. Large language models have parameters that are just like fine-tuning like billions of knobs to give you the right output, okay? So GPT-4, billions of parameters. Mistral, an open source company that makes large language models based in France, they have a model called Mistral 7B. That means it has 7 billion parameters, which is actually much smaller than the bigger models. This is cheaper to run, runs on my Apple Silicon, on my GPU. I can run it locally, and I can fine-tune it, meaning I can train it for my specialized use cases. This is the future of AI. Because the big models require way too much compute, way too much resources to not just train, but also run. And so as we move towards a future, we're going to look at smaller, fine-tuned, specialized language models that are democratized, meaning we can all run locally on our machines. And so if you're interested in further study, I'd recommend those two. Let's summarize all that we talked about today, as ChatGPT would. We looked at the question, are you an AI engineer? We looked at a diagram from Swix that Andrej Karpathy, head of AI at various companies, has corroborated. There's a line between machine learning, the line is the API, and then there's AI engineering outside of the black box API. This is like fetch from OpenAI. We established that. We established problems with AI, RAG as a solution for hallucinations, for finite context length, and for knowledge cutoff dates. Finally, we looked at a demo with Langflow on how RAG even works, and we literally taught GPT 3.5 Turbo something new. This whole Nike thing, it didn't know about it. It literally said there's no Python framework. Later, we taught it, and there was. So this is how you can extend it for your workflows. And finally, we looked at generative UI. That's all I have for you today. I hope this has been useful. I hope this is accessible to you. Thank you so much for having me at JNation.
Okay. Let me just get upstairs. Do we have sound? We do have sound. Okay, so we finished the talk with 2 minutes to spare. I'm gonna tell you now, because they just ended. What a great talk, right? So up next, now we're gonna have like a 20-minute break until midday 10, something like that. And then we're gonna be back with Attila to talk about taking the web native. So with Tauri, which is going to be a very interesting talk. So what I'm gonna ask you is, like, obviously have fun on the break, check our sponsors, have some food, some coffee, recharge yourself. But try, if you're coming back to watch the next talk, try to be here on time because we're gonna be very sharp because there's gonna be rotation of speakers in the next slot. So thank you so much for being here. Thank you to Tejas. Tejas will be back for our discussion panel later on, and there's gonna be some surprises related to Tejas in a bit later. So see you all in a bit. Have fun.
Thank you. It was fun. Yeah, it was nice. Is this on? Oh, my mic is still on. Say hi to everyone, Elian. Hello. Thank you. It's nice to see you. Thank you. Good. Thanks. Thank you, man. Appreciate it. Thank you.
at 12:10 sharp, so the clock just turned to 12:10. I'm gonna move up here, or else people from watching from home are gonna get mad at me. So, we're getting ready to start what it's probably gonna be a very solid block of talks. We're gonna have two talks. The first one is gonna be Attila. The second one is gonna be, well, me. And first of all, the first speaker is gonna be Attila. Attila is working as a DevRel lead at Crab Nebula. He's a GDE on web performance. That's it, right? Something like that, yeah. He'll tell you all about it. He's also part of the Solid.js DX team, and he's also a very good friend of mine. I've learned a ton from Attila. He's a very, very great, very, very good engineer. So I would like you to, even for the people who are still sitting and entering, to give like the warmest welcome that you can to Attila Facina.
Can hear me, right? Yeah. Great. So, yeah, let's get started. So first of all, we're going to talk a little bit about Tauri, which has anyone here have heard about Tauri before? Cool. So to the ones of you who haven't heard, we're going to talk a little bit further onto that, but there's going to be some Rust language involved. And so to the ones of you who, as I am, are often a little bit scared of Rust, I brought Nova here. So if at any point some scary Rust code shows up, you can focus on her and it's gonna go away soon, I promise. But yeah, before that, who am I? As Daniel already said, I don't wanna mess up with what he said because it was better than what I can say for myself. A developer relations lead at this company called Crab Nebula. I work with a Solid.js developer experience team, and I am a GDE for web technologies. Because naming things in the web is hard, I put like these nice shortcuts on my own website, so you can find me anywhere. Just appending the social media name to this to my own domain. And so yeah, we have quite a few stuff to talk about, so let's get started, right? So first of all, as I mentioned, Tauri is a framework for building hybrid apps, hybrid and native. There is a use case for building native apps, but essentially hybrid apps, and it is powered by Rust. So what I mean by that is, first of all, this on V1, which is the one we have today, we can build desktop apps. We can build for macOS, we can build for Windows, and we can build for Linux. And then on V2, which is right now very close to reach a release candidate mode, so the APIs are quite stable. It's about to, like, we are very close to have a stable release. It's on the security checks. You, on top of the ones you can already build, you can already create binaries for Android and iOS. But yeah, but how does Tauri accomplishes that? Tauri, as I mentioned, is based on Rust. So it has two main components. The first one being the native window management system, which we call Tau. And it's built on Rust, and that's the part that makes the connections with the system calls. So you can actually write native code with Rust. And then it wraps the native web view. And with that, because you're writing on a web view, you can use whatever web framework you want. So basically, you can take any single-page application app, or even like any web app, actually, and you can wrap it into the Tauri web view, and that allows you to ship it to create binaries for all of those different platforms I mentioned before. But what's the deal with that? There's so many other frameworks that already do it. The first thing that people notice, besides the speed of Rust and the security of Rust, and these things that Rust empowers, being the backend language for us, is that, as I mentioned, it wraps the native the native web view, and it connects to and it allows you to write native code, which means your app is as big as your bundle. And when I say that, I can say, like, for this little example of mine, where I already shipped it, here, can you see this? Yeah, so as you can see here, I have here like the binaries for each one of the desktop apps that are possible, and this is the size of my app for the Apple Silicon. You'll see that the Apple Intel ships the universe with it, but then again you have like the Windows, and you have the Linux ones that are like 3 megabytes and 2 megabytes. So that's a huge vantage point for people that are coming to Tauri. They realize that it can actually ship very fast, secure, and performant apps. So that's why I find it so interesting. And we'll talk about Pulsar in a little bit longer, a little bit more. This is actually a demo app that I wrote because I wanted to learn Tauri. So I jumped into it with a JavaScript mindset, because I'm a JavaScript developer, I'm not a Rust developer. Which leads me straight to addressing the elephant in the room. Tauri is great, but do I need to write Rust for it? Do I have there are people that are Rust enthusiasts here, or are you confident with Rust? Or, yeah, me neither. So the thing is, you actually can. So you can actually write Tauri apps without Rust. I actually use Tauri to learn Rust. So I can get pretty far writing JavaScript with Tauri. And then when I actually need to do more stuff, or when I want to do more stuff, I can now jump to Tauri. So I can jump to the Rust backend and do other stuff. That's what I did with Pulsar. So for example, Tauri is going to expose a set of APIs that you can communicate directly to the system from JavaScript. So these are type-safe APIs in TypeScript that you know exactly what the system is gonna give back to you, and then you can do it. On V1, if you were familiar with Tauri before, this was a much longer list. For V2, they're actually split now, so you also have plugins where you can then connect and use. So we have way more stuff than we had on V1 now, but they are separated for making it easier for you to deal with it, and also because when we bring mobile to the story, there are a lot of APIs that are available somewhere and they're not available somewhere else. So then you can actually be able to manage those kind of things. But yeah, as I mentioned before, if we're learning, we got to be able to debug, right? So unfortunately, to this point, Rust is not quite like JavaScript in terms of you cannot console log stuff where you want. You cannot impact the runtime and so on. So that leads to the first integration tool that I use to learn Rust and to learn Tauri. That is a tool that I actually work on, so it's a little bit of dog fooding for me, because we created this tool called DevTools that's essentially supposed to be what Chrome DevTools is, but for a Tauri app. And the way it works is actually, I have here my code base. So let me, this looks horrible. Okay, so let me just change. That's very bright, sorry. Do I have something else? Pesto? No, I don't. Sorry, let's deal with that. Okay, so it's gonna be short. So what we can do with this is essentially like, a Tauri code base is essentially like any other JavaScript code base. You have the source, and as you can see here, I have this is actually, sorry for the logo, this is not a React app, this is a solid app. But you can have your JavaScript app as it is. This essentially can, to be honest, it actually compiles with the Vite. I have my Vite config right here. There are a few specific configurations that I like. I lock the door for the port for my dev server, and I make it break if it's not there, because Tauri is going to be listening to a specific port. I have some inf prefixes that are for Tauri, but other than that, it's just a regular Vite app. And then the magic starts happening on my source dash Tauri. So in this case, you can set up your stuff over here, and then in the main, what I wanted to show you is actually in my lib one, where I can connect my DevTools, just like that. And this is a little bit more complicated because I put here a conditional clause because I only want my DevTools to be plugged in when I'm on dev mode, because I want my binaries to be small and my users don't need to debug my app for me. So yeah, essentially I'm just connecting to the builder and I'm adding my DevTools plugin, which allows me to then come over here and say pnpm Tauri dev, and once I run, it's going to compile. Hopefully, so it starts the Vite server and then it compiles the app. It should be fast because I compiled a little bit earlier. Because yeah, the first build can take a little bit longer with Rust. And then, okay, once it's done, I have my app here. But what I wanted to show you about the DevTools is that the DevTools actually exposes to me this little URL. And then if I come and click in this URL, it actually opens my app over here. And then I have my console tab. I can actually debug the calls that happen to my system. I can debug my config. And I can check like which are the attributes that I set and what do they mean. So what is a CSP in this case and how do I do it and so on. And where is this entry in the docs and etc. So let me see if I can I think I need to do this. Okay, so now I'm in the full screen, whatever, yeah. And what I wanted to show you is that it's actually connected live to my app. So basically, as I move my window, you can see the logs coming up, and we can actually do some scanning here, because that's what my app does. So this app is supposed to scan all my node modules recursively, go deep into them, measure the size of each file, sum it up, sort, and bring it back. I have a few big repositories here, so it's going to take a little while. But essentially, this is what's going on in this case. And then you can sort the attributes. You can see that the call was thrown. And then I have my glob regex. The number of the directories came up. So I have 174 directories, the same one as I saw here. And then I have all my node modules per size. And then there's one that I don't want to do it. I don't need to work on it anymore. And then I can just come here and delete with the native APIs. So that's essentially what Tauri is. And now I can close it up. As I close, it realized that my connection was broken. And that's it. So this is the first one. So with this, as you can see, we can then start debugging as you would. So I can log stuff to my console, or something close to my console at least, with the DevTools. And that's cool and all. But then, once we debug, once we learn, we want to ship our app, we need to optimize. And then again, I'm not a Rust developer. But I talked to Rust developers, I read docs, and basically you can go to your cargo toml and you can define a profile release. So that's what I did. So I set all this weird stuff that doesn't mean anything to me. And then I know that the panic abort means that I'm going to strip expensive panic cleanup logic, which means that on dev mode, what Rust compiler is going to do is have some additional information for wherever your program panics to let you know why that panic was caused. You don't need that in production. Then you can actually make your compilation time sequential. So what Rust does is essentially grabs all your dependencies, compiles all the dependencies, and adds to your build. So with this code gen units, you set it to 1. It makes sure that it's going to compile one dependency at a time. So that allows you to optimize for a smaller build optimization. It can make your CI takes a little bit longer, but it pays off on the binary. So that's a metric that you can play with. Then you have this LTO true, which allows some link optimizations between your dependencies and your code. Finally, there's like, this requires some fine tuning, but in a general manner, if you add the opt level S, it means you're going to optimize for binary size. In some specific cases, they're not that common. You're going to see your build times going a little bit too high. So you if you have a big Tauri app, you might want to check that. That would be the first one you would look. And finally, this I think becomes default in Rust in some new versions, but I'm not sure. But then the strip goes through, it means they're going to remove a bunch of debug statements from your build profile. Then again, because you're saying profile release, that's essentially your prod build in JavaScript language, I guess. But then again, okay, so you wrote your app, you got as far as you could with the API configs that Tauri exposes. You got something working, you know your app is looking good, and now you feel brave, right? You want to go there and dive into Rust and do something with Rust. So for that, we can actually do some optimizations for our performance. One of them is this, my favorite one is actually this package, this crate, actually from some friends of mine, that's called RSPack. So Specta is another crate that's gonna generate TypeScript types out of Rust commands and methods. RSPack is the wrapper for Tauri of that Specta, so both are maintained by the same people. Essentially what happens is you have your Rust command, and then there's one command that you actually want to expose to your TypeScript runtime for it to be able to invoke straight from there. What's going to happen is that on compile time, Specta is going to generate the types for you, and then it's going to expose, generate a new file, TS file, that's going to expose the commands object, and that commands are going to have all the keys of the commands you exposed. In practice, what it looks like in V2 is like this. Then again, this is Rust code. I don't expect anybody to look at this and make sense of it. At least, yeah, it takes a breather. But what I want you to look at is these parts. So you're going to take an array of your commands, and then you're going to define which path those commands are going to show up. And then once it does, it's going to look like this. So the commands is going to give you this get dir data, which is the camel case version of the snake case name. And it's going to give you a promise with a result. And then result is kind of a translation from what Rust is. As you know, Rust demands that you deal with errors. So if you can see this result here, it's either going to be a success or an error, which means that then we have a status OK with the data that's going to be the result of your actual invocation, or an error, and then it's going to be one of the errors you treated. So yeah, essentially that's how it goes. So with this, if we jump into my code base again, I can show you this part, because there is no system API to check all your node modules, so I had to write it and then expose it to my JavaScript. So what we did is essentially, no, that's not what not this, here. So we have this get directory data, and this get directory data, as you can see, it's gonna bring back exactly the type that RSPack created for me in TypeScript. So it's gonna give me my folder stats, vec. In TypeScript, vec goes in as an array as well, but yeah. And then the error. So then with this, I can either have, yeah. So with this, I can either have an OK, which is going to be the status OK, that's going to bring me the folder stat with the path of the file and the size, or it's going to give me an error if it's not OK. Then I join everything, I order, and that's it. So this method gets exposed to my commands, and then it goes straight into my TypeScript bundle, and there you go. So it's exactly the same code written in 2 languages in this case. That's what Specta can do for us. Okay, so that's it. We got some great DX. We know what we're doing, and we know what to build. The next step for us that never built like binaries, or never distributed, or never shipped to an app store, distributing can be quite hard. So to the point that you need to sign your app, you need to have certificates, and then the binaries, sometimes they're not so small as we saw. So in order to do that, you also need to integrate somewhere. You need to distribute somewhere. You don't want to handle all this logic. So this is actually the product for now is free in Crab Nebula. This is the one I'm using. I can release a distribution, and I can also set an auto update. So basically with this, I can create a GitHub action that looks roughly like this, and I'm gonna pass my signing keys, and I pass the matrix of all the platforms I want to build for. I pass some other keys, like for the auto updater, I need to pass some extra keys and stuff, and that's gonna handle it for me. So then with this GitHub action, every time I merge to main in my GitHub, it actually creates that release that I showed you before that has all the binaries that I want to have, and then I get a nice link that's distributed. But yeah, I've been talking for almost 20 minutes nonstop about things that you need to set up, right? Once I started doing that, I realized, okay, I don't want to do that again for every single app that I want to build, which is why I started doing this. So I grabbed all the nice things that I got because I realized, because I'm working on a company that's very much Tauri focused, and I'm building a bunch of products that are Tauri focused, I'm going to create a bunch of sample apps, or I want to be able to create apps to do that. So as I started doing that, I mentioned, and some people let me know that they wanted it. So this is actually Quantum, my little template that's super, super opinionated, to be honest. But it just brings everything that I want to have in my app for me. It brings me the debugger, the dev tool for the debugger. It brings me Specta. It adds some Tailwind that doesn't come out from default on the Tauri templates. It uses Solid, creates the release profile, and set up the GitHub actions. So with that, I set up my GitHub repository. I start writing my code, and then I can ship to all the apps as I start merging to main. So, and I can show you how this works since we have a few more minutes. So essentially, you're going to have to believe me because I'm not going to clone the whole thing and npm install on a conference Wi-Fi. But let's see if I go to my app over here. So this is my Quantum repository, and then I can just go here and say, yeah, pnpm, Tauri, iOS, dev. And then as I run that, it's going to start compiling. It's going to ask me, OK, so which one of these iOS systems you want to do? I ran, yeah, the iPhone 15 simulator the last time, so it's already installed. This is all running with Xcode and stuff like that, so if it's not actually installed, you might have to download around 7 gigs or stuff like that of the device image. So that's why I'm using one that I already did. Once I do that, it starts building the app for us. A lot of stuff in the console. Takes a while. But once it does, you actually have the hot module replacement, as you would in any other JavaScript environment. So then it connected to the remote UI, which means it's then now going to start installing the app and archiving some app, and then the connection, and it's going to start the app, and then once it goes, it's going to come up over here. And deploying the app to the device. And once it's done, we have a JavaScript app, a Tauri app written in Java. So that allows me to then say something like this, and I can send it. And then this message goes to Rust, runs some native code, and brings it back. So we got an iOS app. And having the Android app is just the same thing. I can go Tauri, Android, dev. And then it's going to start the simulator again. This one's a little bit faster. That's why I left it for later. And then it loads, starts installing, runs the Vite server, bundle the app, and Pixel needs to wake up. So as you can see, it takes a little bit of time because there's a bunch of compiling stuff. It's actually compiling the thing and initializing the configuration and so on. And then once it's done, I said once it's done. Okay. So yeah, as you can see, some of the builds, they're gonna vary based on the platform you are in. The macOS is, the macOS is more or less the fastest. So then again, you can do the same thing. You can use the native one, the native keyboard, or your keyboard. And as you can see, this thing is not super nice. Yeah, but you get it. And then all the other ones, you can do the same thing, and that one is way, way faster because it's just using my native one and runs all of them. So this one we already saw before. And then you have the actual stuff. I need to finish this one. And this you also have the native app. So with the same code base, you can ship everywhere. And yeah, so that was what I had for you folks. I hope you have enjoyed it. And again, feel free to reach out to me on X or Twitter or YouTube, whatever you prefer. And thanks a lot. And now I actually need to switch hats because I need to talk about this other guy that you already met. Daniel Afonso is our MC, our host, local Coimbra guy. He works with me at the Solid DX team, and he's now about to talk to you about Solid Start, which just came out on a stable release, so he has a bunch of cool stuff to mention. And please welcome Daniel.
Tired of me already. I just have two questions I already asked. The first one here is, who has heard about Solid.js? Who has used Solid.js? And who has watched Dune? Yeah, this question confuses some of you. Because I want to make a small comparison. Because, you see, 6 years ago, Solid showed everyone the way, showed everyone the path. And this path was all about fine-grained reactivity. This is a slide that I stole from my previous speaker, Attila. Thank you for this slide because it saved me time on implementing this. And the thing that Solid showed the way was all about fine-grained reactivity. You see, we had these systems who were more coarse-grained reactive, things like React and other frameworks, libraries, however you want to call them. I won't go into this discussion. They used to be more coarse. This meant that the framework had to run code to identify what changed on the UI, and then run code to update it. Whilst when you have a fine-grained reactive system, you have this primitive called signals that enables you to basically not need to run code to update the UI. The signals just tell the framework, hey, update this specific part. And this is basically, in a very, very small nutshell, how fine-grained reactivity works. And this is where we started 6 years ago. This is where we were when Solid first showed up to the world. And this is where we are right now. Almost everyone is all aboard with fine-grained reactivity. Almost everyone saw the value of signals. So it took a while, but this is basically where we are right now. And it was not just us, the developers, that won. Our users also won because of this, because our apps are more performant, they seem snappier, and, well, for the developers, we have a better developer experience and a clearer mental model. Now, while this was happening, there was another discussion that showed up, well, 2-3 years ago, something like that, and it was all about the server. We were wanting to bring stuff back to the server, stop having stuff running on the client. Server-side rendering now was a topic. Everyone wanted to do server-side rendering. And frameworks had to adapt. they had to have a way to start having server-side rendering. Now, there was an option. You could do this by, well, if you're using React or Create React app, you could eject your application, you could configure Webpack, but that stuff hurts. I don't like doing it. And the easiest way was probably jumping all the way the sandworms, which in this case are the meta frameworks. You cannot see there on the left because of the subtitles, but there's the Vue logo because that's one of the Vue use meta frameworks next. For Angular, we have Analog, and here for React, we have Next. Now, these meta frameworks, for you who are not familiar to what they are basically frameworks built on top of frameworks. And they bring you, first of all, a better developer experience, some opinionated stuff, and these things with multiple rendering modes. So now we had stuff easily interchangeable with server-side rendering, client-side rendering, yada, 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 yada. There was a bunch of stuff. Now, when these meta frameworks started popping up, there was one question that everyone was asking. What about Solid? Where does Solid fit into the meta framework discussion? Because no one knew what was our sandworm. No one knew what's going to be the thing that Solid would use to hop into the meta framework discussion. Well, in 2021, Vite 2.0 came out. That same week, Ryan Carniato, the creator of Solid, said, let's build a meta framework. And he created Solid Start. So this is where I'll start my presentation. I'm going to go to the next slide. I'm not going to introduce myself again, just telling you some other stuff about me that I haven't said yet, which is I wrote a book last year about React Query, 10-stack query React adapter. That's how we can describe it. I wrote a book about it last year. I released a course on Egg.io about React testing library, and you cannot see it again because it's cut. I've been maintaining this newsletter that's this month in Solid, where we will go over everything that happened in the previous month in Solid.js ecosystem. Actually, I just released my newsletter, 4th issue, yesterday. So if you want to check it out, please feel free to. There's this QR code here that you should be able to scan if you want to get more information on this. Either way, you can also go to my social media. I'm Daniel J. everywhere, so you can basically find me. Now, bringing back the topic of the discussion, which is why do we need a meta framework? I could spend a couple of hours talking about this, but I decided to just add these 6 topics. You see, meta frameworks are not just about rendering modes. They're not just about deployment adapters. They're about, well, having an improved developer experience, having proper guidelines, opinionated guidelines, and all these things will basically help you have a faster time to production. It will help you ship faster with hopefully more quality. Now, there's one keyword here that when people start talking about frameworks, that's what people start getting triggered, which is opinionated. You see, there's this idea in the JavaScript ecosystem, and that's what I can speak for because that's where I feel like I belong and where I'm hanging out, that when you have something opinionated, you don't have freedom. People don't like being locked into stuff. People like to, well, if I could change libraries every 2 weeks or so. Obviously, that's not viable, but that's something that we like, I would say. And when you have something that's opinionated, you lose the freedom. I can give you a small example. 2 years, wow, it's been 2 years ago. 2 years ago, this meta framework from one ecosystem released a new router. And when that router released, everyone was losing their minds because now, like, oh, there's new stuff. I have to learn this stuff. It's opinionated. I don't like it. I want to be free. I want to use whatever I want. And I'll come back to this part in a bit because I want to center the question again. What about Solid? What about Solid's meta framework? I told you that when Vite 2 came out, that week Ryan started working on Solid Start. But this was in 2021. It has been 3 years. Well, Solid Start went to multiple rewrites, 2 beta phases, because we wanted to build the best thing ever. Ryan and the core team from Solid said, okay, we want this meta framework to be the shape of frameworks to come. That's the way that they want to show to other frameworks, to the other ecosystems. And since, well, Attila has already spoiled this, 2 weeks ago, Solid Start V1 was released. So now it's stable. There was this concern that, oh, the app is still not stable, so I don't want to give it a shot. Now it's stable. It's there. You can give it a shot. Just do npm, npm, whatever, create Solid, and you have your CLI to customize your application. Now, let's talk a bit more about Solid Start, because solid start is all about composability. And what do I mean about composability? I also stole this slide from Attila. Composability, it's about, well, I'm getting a bit ahead. Meta frameworks are about 4 things, or 5. The UI library, or framework, the router, the bundler, the server runtime, and in this case, a serializer. And these are the things that compose a meta framework. And in Solid Start's case, this is what we have. We have Solid as the UI library. We have Cerevel, which is our serializer that we had to build basically from scratch because it's super powerful and it needed support stuff that other serializers didn't. I wish I could talk more about it. You can ask Attila about it because he knows way more about Cerevel than I do. Because this thing is crazy, it's super advanced, and okay, it makes my head hurt just trying to process everything. But either way, then we have Vinci. Vinci is basically the bundler and the server runtime wrapper that we have. It's basically built on top of Vite and built on top of Nitro. So Vite is basically our bundler and Nitro is our server API. Vite basically allowed Solid Start to be created. It's the thing that gave hope to Ryan and said, okay, let's build this thing. Nitro, on the other side around, the reason why we went with it is because it's the same thing that Analog is using, it's the same thing that Nuxt is using. And one thing that I've learned about the Solid.js ecosystem, even before I joined the DX team, was we're all about learning and growing from each other. And because Nitro, it's being used by these other meta frameworks, we got to contribute together, we got to learn from each other. And we get to have this stable foundation that, well, hopefully if one of us finds an issue, that will help all the others. And this is basically, I could throw a Mandalorian reference, the Solid way. And then we have our router. We have Solid Router, which is basically the thing that had already existed before Solid Start. And when I said that Solid Start is composable, it is because we tend, and one of the intentions that Ryan had very much in mind when building Solid Start was, I don't want it to be opinionated. I want to have freedom here. I want people to say, if I don't like Solid Router, I want to bring my own router. I can bring 10-stack router if I want, as long as I could make my own router. As long as that router can speak Solid Start, so there might need to be some changes, you can take Solid Router out. You can swap these things for something that you want. There's not the freedom aversion to it. We want to be free, and this is what we have. Now, enough talking about how Solid Start works. Some of you are thinking, okay, yeah, this is pretty cool, but what are the features? What does it do? And now I will try to do a small demo that the last time I presented it in 40 minutes, so I'm going to try to do it in 10. So let's figure out how this works. Okay, let me just open Visual Studio Code. Before anything else, this is the application that I'll be playing with. So I work at OLX, and one of the products that we develop at OLX is Sun Virtual. And basically, this is a very, 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 very dumb version of Sun Virtual where you can just add cars, see cars information. So if I click here, I should be able to see my car information. If I go back, so we have routing. And if I come here, I can add a car. I could show you adding, I'll show you adding, but let's not jump ahead. So this is basically the application that we'll be working with today. Now, let's open our Solid Start app. Let's put this full screen so people in the back can see. I'm just going to close everything here, get back to our app config. And our app config is where everything starts. This is basically our Vinci wrapper that's going to basically expose Vite, Nitro, and you can expose your configurations. Here I'm just going to disable SSR for a bit because I want to show you this working in a single-page application, which is what most people, the majority, might have. So we're building a single-page application right now. Okay, so our application will start with our app TSX. Our app TSX is basically where we expose the router and where everything starts in our application. So we have our router there, and this router is wrapping basically a main where we have the image from Sun Virtual and a suspense boundary. Basically, whenever we're loading a route, there can be the route might suspend. So while we're loading the data, there's going to be a fallback showing loading, and then it's going to be rendered inside of props children. So for those of you who have used React, this might be very familiar. It's also JSX. And then here we have this thing called file routes. You see, file routes is very peculiar and it's very important because it's here to solve one of the issues that bother us in web development. But the way, let's before jumping any steps, file routes is here basically to tell Solid, okay, we need to load some pages. And how does this work? Well, we look into this routes folder here, and if we want to render the index page, which is our slash page, we're going to have our index component. If you want to render the new page, which is going to be our form, we have the new component. And if you want to render like cars/ID, which is basically the number that we want to fetch from the database to get our data and load it, we use this syntax here. So basically, we have square brackets ID, close square brackets TSX, and basically what this is going to do is look at the URL, grab the ID, inject it here, and then we can use it for data fetching. Now, this by itself, it's not very exciting. What's exciting is basically what file routes does. Because let's imagine a typical application. First, we render our index, which is in this case our app config. Then inside of our index, we're going to render our page, which is going to be one of those components. So we fetch the index, we fetch the page, and then our page is going to need some data. So then we fetch the data. And there's this waterfall starting to happen. And this basically affects the initial page load of our application because, well, if you have to do all this data fetching, your page is going to take longer to load. And this affects conversion. This affects companies, and this takes money away when pages take time to load. So let's start to fix that. So basically, the app and the index boundary, so these two layers, can be fixed with the help of the bundler. The bundler can be smart enough to figure out, okay, we need to add some preload tags to these components, so we can fetch them in parallel. The way we can fix the data loading scenario, it's by using this thing called loaders. Loaders allow the data to be, first of all, preloaded, and basically this means that while the page, the index and the page are loading, the data for the page is also loading at the same time. So instead of going 1, 2, 3, you have 1. All the 3 layers are fetched at the same time. Also, file routes does one thing super cool as well, which is it lazy loads all the components for you. You don't have to use React, the thing with Solid that's Solid lazy, which is very similar to React lazy. You don't have to use this to do code splitting because file routes is smart enough to figure out, okay, this needs to be lazy loaded, so let's wrap it automatically. I told you about loaders. So loaders, in this case, can be exposed from one page by saying, okay, export route, and from this route we have a loader. And in this loader, we get cars. And that's basically what we're doing here. We're saying, okay, for this route, we're going to need this data. And we're going to fetch it, preload it. For instance, I can show you this working here. Just go over here, inspect. I'm going to zoom this a bit. If I go to my network tab, that should be, if I over this, you should see that there was a request happening here. So I don't know why it's failing. I don't know if I killed the server. But basically, there's the preload fetching. So what would happen here is there's a preloading. I click. Here we already have the data. Now, there's a reason why we already have the data here, and that's what I'm going to talk to you about. Because inside of this component, we also have create async, which is basically a solid router primitive that allows you to turn a promise into a signal. That's basically what this does. And this create async also basically calls our function getCars, which is our query to the database to get our data. Now, this is where the fun story begins, because who here has used Remix? Just a question, okay. Some people use Remix. In Remix, when you have loaders, you have to basically, you return your data from the loader, and then you use this thing called use loader data. And from that, you have access to the data that your loader returned. This is not how it works, because if you have used Remix, and then you're using TypeScript, you're going to figure out that, every time I return something from the loader, I have to do like type of loader just to make sure that our data knows what data is. So there's some type safety constraints that we need to be handled in Remix. In Solid, we didn't want it to do that. We wanted to basically, I fetch data there, and I fetch data there. And now you might be asking, but Daniel, doesn't that mean you're going to fetch data twice? It does. Ideally, we would have something like 10-stack query, or React query, where basically what it does, it's a cache layer built on top of your network layer. So when you get the data, you cache it. That's a very short description of how it works. So that's what we built. Inside of our getCars, which is basically your function to fetch some data. This function is wrapped with cache. And then we have a query key here. So what this is going to do, it's going to fetch this data, cache it under cars, and this means that when the preload request it and the loader request it at the same time, this is going to be smart enough to tell you, okay, there's already this promise running, we're going to wait for this promise to finish, and we're going to get the same data to both of you. And that's basically how cache boundary works. Now, there's something here that you might find interesting, because there's this thing here that says use server. Ooh, what is use server actually? That's a question that a lot of people have asked themselves. Oh, it's there to run stuff on the server. Yes, but most of all, use server, it's an annotation for the bundler. It's there to tell the bundler, hey, whenever you see this tag, this part of the function is going to be extracted and only be executed on the server. So if you have a client-side rendered application like the one we have, what's going to happen is, because this function needs to run on the server, there's going to be an RPC call from the client to the server fetches the data, and then returns the data via the RPC call. This is if we're doing client-side rendering. If we're doing server-side rendering, it just runs everything on the server, renders it there, and then you get the page. That's a bit the gist of how use server works here. Now, I still have 6 minutes. Okay, so basically here we have what it's called a server function, because this function is always going to be running on the server, and then the data is going to be cached under cars. The same thing happens to getCar, which is the function to get an individual car, and then cache it under the query key car. Now, some of you might ask, but this is going to get multiple cars. How do you cache it only under single query key car? Well, because we have a parameter here, which is ID, what cache is going to do is get this ID and serialize it together with the query key. So there's going to be car/1 or something like that. So it's going to always cache it under that thing. And this is basically data fetching and caching. Now, let me figure out where I was in my story. Okay, so I showed you the index, fetching data, create a sink, there's a cache boundary here, so it makes sure that when we preload data, it won't refetch a bunch of times. And also, another very cool thing about create a sink is this thing is going to be type safe, because we're using the exact same function that we use to create the data on the server. We're going to be able to know what everything is with the help of TypeScript, which is pretty cool, and one thing that we would lose if we were just using like a fetch call and an API route, which you can still build because Solid Start is a meta framework, so you can have API routes if you so desire. I have 4 minutes, and I just wanted to show you the thing that really excites me now. So let's look at our form, shall we? And I still don't know why this thing is failing. Oh, I know why it's failing. Let me restart the client. So let's load everything again, and let's add a new car. So we're getting into the mutations territory. And in mutations, in this case, we have an action, which actions are the ways that you can be called inside of a form, and this thing will do an action. We're going to do something really cool here, because let's visualize how forms and how submissions work. Usually, you have you execute a mutation, which is a call the post request to your server, and we expect, okay, this needs to create data on the server. Cool. So when the post finishes, the client then figures out, okay, I want to go back to my index page, which I don't want to stay on the form. So I want to go back to my index. And then when you get to the index, you're going to have to load the data again. So there we go again, 1, 2, 3, waterfalls. And we don't like that. So let's look what happens when I submit this data, shall we? We're expecting those 3 waterfalls, those 3 requests. So brand, I have no zero about cars. So if these models don't exist, don't judge me. I don't know the pricing here. And I'm just going to put a bunch of stuff because there's some form validation here. Is Tejas trying to pronounce this? He was trying to pronounce this. This was really cool. Sorry, the view from here is super fun. So let's create a car. There was only 1 request. How? What's happening here? Why is there only 1 request? Well, this is the power of something that Solid Start has that I really, really love. Sorry if I get excited. It's called single flight mutations. What's happening here is when you send a request to the server, and now let's look into the code, because now I need to show you this. When we call our action here, that's the add car, what's going to happen is this action knows it needs to update data on the database, but this action also knows that it needs to redirect to the index page. And this is the power of having a router that knows all your needs. Because what's going to happen is, it does the mutation, it sends the next page already to the client. So what the client gets is the next page, and at the same time starts fetching the data on the server and streams it in. That's basically the power of single flight mutations, all in a single flight. This thing is crazy, crazy exciting. I just love it so much. What haven't I shown you yet? I still have 2 minutes. So, well, let's disable JavaScript, shall we? Because this is a meta framework stuff, so we need to disable JavaScript. Disable JavaScript. Let's run. And we have no application. Anyone knows why? Exactly. This is a single-page application. We're doing client-side rendering. I disabled server-side rendering in the beginning. This has all been done from the traditional application that we have nowadays. So now if I wanted, I could go back to my app config, and I can just say true. I wouldn't even need to do this because by default it does server-side rendering. And if the dev server is working, the JavaScript is still disabled, and everything still works. Progressive enhancement. That's all that it's about. So now I believe I showed you everything. If I forgot something, I would love to chat a bit more. I'll be here all day. And let me open my last slide. So, play. Cool. So I showed you some of these things. I didn't show you stuff like optimistic updates. I think I showed you pretty much everything. But there's many other stuff that Solid Start enables you. There's an experimental islands on the way. It's already there, but it's being worked on. There's, heck, now my brain stopped working, but we have so many, many things that are not here that allows us to build like the best experience when we're building solid applications. You see, Solid Start provides us with the meta framework experience that we wanted, without like the convention lock-in that we would expect from other meta frameworks. There is a reason why we say Solid Start is the shape of frameworks to come. Don't like the router? Swap it out. Don't like a specific convention? Don't use it. We give you the primitives for you to build whatever you want and the freedom for you to do whatever you want. Start is here to help you build better with quality production-ready applications. This is, well, this is a start of something exciting, I could say. There's no opinion, no lock-in, just a based start. So with that said, and I'm finishing right on time, this was my time, and I hope to see what you're going to do with Solid Start. Okay. So this was right on time. It's lunchtime. We're going to have 1 hour for lunch. So we're going to be back here at 2 for Marta talk and Mateus. We're going to go over Core Web Vitals and a huge performance case study. So I'll see you all here in 1 hour. are going to be about Core Web Vitals and about performance. Our first speaker of the SWOT is going to be Marta, who is here with me. Fun story. When we were reviewing the call for papers, there were two talks that I said, we need to have them. And Marta was one of the first talks we saw. It like, okay, we definitely need Core Web Vitals because it's a super important thing. Everyone is discussing it. There's initiatives in companies just trying to optimize to that part. So I won't start speaking more or else I'm going to take some more time from Marta. So, without any further ado, Marta is a GD on Angular, exactly. And she's coming all the way from Poland, today. And she's going to be talking to all of you about Core Web Vitals. I hope you all enjoy. Can I just get a warm welcome to Marta?
Thanks. Obrigada. Hello, everyone. My name is Marta Wiśniewska. I am from Poland. I am a Google developer expert in Angular and web technologies. And today, I want to tell you how to keep Core Web Vitals under control and how to improve the user experience and performance of your web apps. And so Core Web Vitals is a universal user-centered set of metrics developed by Google. Can I ask for these slides?
Just a quick tech update. Let's figure it out. That's why we do tech checks. We did. It was working. Now stuff stopped working. Where's the HDMI cable? It's plugged in. So let's double check. Are you receiving the signal there? No? Okay, that's weird.
No.
Just some technical difficulties. Let's try to figure out what's happening here.
It cannot see the wire.
That's weird, because we just did a tech check and it worked. There's at least 3 people here that saw this working.
How many programmers we need to to solve this issue?
You're not getting any signal on stream? That's fun. We can get you back. Do you only need a Google Drive, right? You only need like Google Drive, so it's right. So you only are using the drive. Can try to get you another laptop in the meantime, because that's weird. You have an USB-C address as well? Is this USB-C?
So Core Web Vitals is a universal user-centered set of metrics developed by Google to qualify apps by the quality of user experience. And Google uses this set in the Google search ranking system. And today I will tell you which exactly metrics build this set, what are the reasons of poor results for them, how you can improve it. Later I will tell you about the tools that you can use to measure and debug Core Web Vitals. And last but not least, I will tell you about more practical examples. I will show you my project in which I try to focus only on improving Core Web Vitals on existing Angular project. And before I start, because every time when I speak, I wish I could have an assistant, a person who could ask questions or remind me about some topic. And this time, I decided to bring one. And to select a proper assistant, I had two requirements. The first one, that this person needs to be familiar for most of the users, for the audience, and the other, that it needs to be experienced. And this is my selection. And do you remember Clippy, the legendary assistant from the Microsoft? There is a fun fact about Clippy. So some time ago, Microsoft challenged his users and posted this tweet. And they wrote that if this tweet will receive more than 20,000 of likes, then they will create Clippy emoji Microsoft 365. And as you can see, there is like almost 10 times more. So for me, it's evidence that yeah, people like him. And the second fun fact is this is a Clippy transformation from the initial version in Microsoft to the current one, to the Clippy emoji. So for me, it's like, a legendary transformation from the Pikachu to Raichu, right? It looks like you're not talking about Core Web Vitals, need some help. And this is a very useful assistant, so welcome on board, Clippy. And let's get started. Let's talk about Core Web Vitals. So why do we have Core Web Vitals? So because engineers love to model everything and have under control everything. And one day, Google engineers decided to find a way how to somehow qualify apps by the quality of user experience. And at the beginning, it's quite tricky, because user experience is very relative. So for one person, the app is nice, for another, not. And Google engineers decided to find a universal factors that rather matters for the most of the users, and based on these factors, somehow measure some metrics in the browser. And they decided that the first universal metric is loading time. So actually for everyone, if the app is fast, we like to use this app. The second is interactivity. So how fast the app responds to user interactions. And the last one is visual stability. So how the layout is stable during using this app. So based on these factors, they decided to somehow measure something in the browser. And for the loading, they decided to measure a metric called largest contentful paint. And don't be confused with first contentful paint. So largest contentful paint is the time when the largest content element is visible in the viewport, while the largest, or when the first content element. And yeah, they did so many tests on different web apps in different conditions, and they decided to find like universal ranges based on which users and developers will be able to say, okay, I received this score, so it means that this is rather like average app, like other web apps. And after this so many tests, they created the 3 zones. The first one, this is a green zone, so it means that, yeah, this is a very nice score. And for the largest contentful paint, they decided to keep 2.5 seconds. So if you receive this or less, it's very good. If you receive between 2.5 and 4, it's a yellow zone, and it means that it's not bad, but could be better, could be improved. And for scores higher than 4 seconds, it's highly recommended to be improved. So for interactivity, at the beginning, they started to measure first input delay. And this is the delay after the first user interaction. For example, after first click or after first scroll. But with time, they just had in mind that maybe it's not the best metric to measure. Because actually, the input delay is not the full, let's say, time of the rendering process. And not only it takes, let's say, only the first interaction. But they wanted to use more general one. And this year, they switched to the interaction to next paint. And interaction to next paint also has some measurements and some ranges. So the green zone is 200 milliseconds. Between 200 and 500, it's yellow zone, so it's not bad. But if you receive more than 500 milliseconds, it's rather highly recommended to be improved. And for visual stability, They couldn't measure any time because it doesn't make sense, but they started to measure the layout shift value that actually represents, let's say, the instability. And layout shift value is a unit for one single point, but cumulative layout shift, let's say, sum up all of the shifts, and in the end gives you the value. And I really like to say about percentages of instability. So, for example, if you receive less than 10% of this value is very nice. Between 10 and 25, it's not bad, but could be better. And for scores higher than 25%, is highly recommended to be improved. It looks like you haven't explained a good threshold. Need some help. And it's a nice point, because actually keep in mind that in different network conditions, on different devices for the same metrics, you can receive different scores. And so Google, in their tools, they have like 75th percentile, this is the threshold, just to ensure that they're hitting the recommended target of most of the users. And this is segmented across mobiles and networks. So if you want to measure, let's say, one app, and you have tools in the lab, then rather try to keep the same conditions, because in different conditions you can just receive different values at the same metrics. And now I want to tell you what are the typical reasons of poor results for each of these metrics. So for largest contentful paint and for loading time, the first reason can be slow server response time. And to improve it, first of all, try to optimize your server on the backend side, maybe on database. If it's not possible, you can think about CDNs. So content delivery networks are really nice to improve, let's say, this loading time. They decrease latency, so then they decrease the physical distance between the user and the client. And another tip, it can be caching. You can use service work and just cache some content, especially if your app is static. For slow resource load time, and the main reason are typically big assets, especially assets that are, let's say, responsible for the loading of the largest content element. So first of all, try to optimize your assets, especially images. There is a lot of potential to improve the loading time only by compressing and optimizing images. But also, for example, you can apply some techniques like preloading, especially like preloading the important resources that are necessary to load this largest content element. And the next reason is render blocking JavaScript and CSS. So basically, for this point, try to optimize your code. The less code, the better, not only because it's cleaner, let's say, and easy to maintain, but especially because it's just faster. For client-side rendering, you can consider other options to render up, for example, server-side rendering. And now let's talk about interactivity. So the main causes of poor interaction and to next paint are long tasks. So just try to break down the long task into smaller tasks, smaller asynchronous tasks. Long execution time of JavaScript. So the problem with this point is that this execution process of JavaScript can block the main thread, what means that also can delay other processes like rendering, like event handling, and so on. So try to identify, let's say, these issues, and then try to defer non-critical JavaScript. And for large JavaScript bundles, try to apply techniques like code splitting or lazy loading, just to split the JavaScript bundles into smaller chunks and only, let's say, deliver to the user at the moment that he needs, not all the, let's say, big bundles at the beginning. And for large DOMs and complex CSS selectors, so when the DOMs are, let's say, more complex and also CSS selectors, it means that the browser has like bigger overload, and just it will take more time to load. So try to also optimize it. And for instability, so the first reason is there are elements without dimensions, because if we create a website, we don't, let's say, define dimensions from the beginning, then the browser doesn't know how much space should reserve for rendering elements. So tip for this, try to always define dimensions, both dimensions for these elements. Dynamically injected content, this is also involved with animations, so try to avoid it as much as possible or just optimize. And also, quite often, the fonts are related to the shifts, layout shifts. And there are two typical effects that are related, let's say, to the process of rendering the font, the custom font. So basically, in the browser, if define the custom font to use on the website, and the browser doesn't have this. The browser have different, let's say, behavior to choose how to manage loading this font. So one, it can just wait until this font, custom font will be loaded, or it can display in a fallback font that will be just a system font. And there is like CSS property that allows you to select this property by the program, by developer. And yeah, there's a recommendation to use the optional, to set font display optional, that actually allows you to load the text in the system font, and then it gives you like very small period to load the custom font. And if the browser wasn't managed to download the custom font, then it will display in a system font, and later in the background, it will download the custom font, and then will keep in the cache. And also, there's another tip to preload the key fonts in your web app. So just by adding this to the fonts that are, let's say, prioritized, that mostly are used in your web apps. Now I want to tell you about the tools that you can use to measure and debug core web vitals. So basically, we can divide them into two categories. The first category that are tools in the lab, what means that we will measure the core web vitals in simulated environment. I think the most typical example is a lighthouse, that you can actually simulate the network conditions, the different devices, and so on. And then we receive the results for this metrics. But tools in the field will, let's say, work on the aggregated data, will work on real data from the users. So they're more accurate. But there are also some, I would say, more limits on this side of tools in the field. For example, you will need to have some traffic for these tools. So for the apps that are not on production yet, and you're not able to use these tools. And also, for example, sometimes you have to be the owner of the site. Or for example, like for page speed insights, you cannot see the full, let's say, data, but only the data from the last 30 days. So yeah, the tools in the lab, besides Lighthouse, there are also Chrome Dev tools, and there is the performance tab in which you can check the core web vitals, but also web page test and different browser extensions. In the tools in the field, page speed insights, but also Search Console, Chrome User Experience Report, different browser extensions, and also other real user monitoring tools. And I added this because actually everyone is able to build this kind of tool, because there are open APIs that allows you to measure these particular metrics. And now I want to tell you about the biggest secret how to keep core web vitals under control. So there is a nice integration of Lighthouse with budget.json file and GitHub Actions. So actually, by integrating this, you will run kind of tests, automatic tests, that will test your, let's say, these metrics. And this is how it works on the Lighthouse side. So actually, you need only to configure this JSON file, and you can specify the metrics that you want to track. So for example, cumulative layout shift of first contentful paint. And then actually you can configure the GitHub Actions in this way that with every, for example, pull request, you will run these tests, and then actually we'll see how during the development mode, you can track the process, let's say, how it will impact the user experience and the performance. And this is the page speed insights, how it works. As I told you, it only measures and shows you the data from the last 30 days. And also sometimes you cannot see the data for some apps if they don't have enough traffic. And the good thing about this tool is that it's very easy to use. You only need to have the access to the app, and you don't need to be, for example, the owner of the app, of the site. And actually, I think it's the easiest from this category of tools, the easiest to use. And now I want to tell you how you can build by yourself this kind of tool. So there is a Node.js library called Web Vitals that gives you just the functions that will give you the result for these metrics. And this is the example, of course, the basic one. And you can see the output and the model of the response. So you will receive, of course, the most important thing, the value, but also, for example, the entries, so the, let's say, nodes of the DOM that are responsible, let's say, for these measurements that are related to this measurement. And what you can do, like to build this up, first thing, you can just keep this data in the database. You can send to the backend from frontend, measure on frontend, send to backend, and keep on the database. But another thing is that if you don't want to, for example, to use backend, you can integrate Google Analytics. So then you can track this metrics as a Google events. So you can put the value as the event value. And then without backend, without database, you can just analyze them in Google Analytics. So this is another way how you can track by yourself the core web vitals. And now I want to tell you about the demo app. I will show you the app that I built in the past. And I only wanted to focus on improving the core web vitals. And it's funny because I built this app many years ago when I was a student. And my first reaction when I saw the code was, when you see your code after a few years, sometimes it's a bit funny. And you can find some issues, at least one, and then more. But then you think, OK, maybe it's not so bad. So some refactoring, it's not so bad. But yeah, the most important thing for me was just to focus on improving performance and user experience by applying the, let's say, Google recommendations and also all the tips that are, let's say, on the internet about the core web vitals. So I want to show you the app. So it was built in Angular, and there were the 3 main tabs. The first tab, it was like product list, like in e-commerce website. And I could switch the results, but there actually were not too many. There were like 100 results. And more problematic was the second tab. It was a blog where there was like 2 very long lists. The first one included photos. And as you can see, there's like, I think, more than 5,000 of items. So they were not super, I would say, performant. Like interaction worked quite well, but actually the rendering process had some issues. When I switched to posts, there's also so many elements, but on this side there were not images. So actually there were not too many issues. And on the last tab I had like kind of YouTube player. There was a carousel with some thumbs, and when I click a thumb, then I could play this video from YouTube. So OK, I started to analyze. I was thinking what to improve. And at the beginning, I wanted to focus on, let's say, on the worst thing to find maybe something that could be really crucial for me. And yeah, I wanted just to measure these metrics in the easiest way. I didn't have it on production because it was my local app. So I had to use like the simple IndieLab tool. And I decided to use this one. It was a browser extension because it gave me the metrics that I needed. And also it showed me, let's say, the result in which zone they are. And I found that the biggest issue is with cumulative layout shift. So yeah, it means that there is something wrong with my instability. And yeah, I applied the first tip that always I can see when I read about cumulative layout shift, about dimensions of images, iframes, and videos. And yeah, here you can see that in different way you can define these dimensions, but also there is a nice CSS property that allows you to not assign both, but assign one and add, let's say, the aspect ratio property that will calculate the second dimension. And this was my first learning, and also a tip for you for example, in the future where you implement, and always add dimensions to your images, videos, and also iframes. The second thing I did, I applied lazy loading because I had so many images on this website, and I did it in a native way. So I just type loading, I set to lazy, and yeah, Clippy is asking, what is the browser support for this feature? And actually, I am very glad because you can see that right now it doesn't work on Internet Explorer, but OK, we don't care anymore, right? Opera Mini, but it's like very niche, I would say. But for most of the modern browsers, it works. And I'm very happy, because I remember when I presented this talk maybe 1 or 2 years ago, I remember that the browser support wasn't very well for this feature. But with time, I am super happy that also the, let's say, the browsers work to improve it. And also they make, let's say, the developers' life much easier. So right now, you can only set this loading property. And it's very, very easy without additional implementation on JavaScript. So the second tip is second learning, lazy load images and iframes. Now I want to show you the last thing that I did related to the third tab with the player. So I noticed that the rendering time, let's say, is quite slow for this tab. And I found that I did a big mistake, because I implemented the thumbs of this carousel as iframes. And actually, it doesn't make sense, because it was really, really blocking. It was very slow. So what I decided to do, I just decided to replace with normal images and only leave the main iframe that was playing the video as an iframe. And it was my next learning and next tip for you. So always try to use the lightest possible elements in your web app. And I want to show you a trick how you can save any node element in Chrome Developer Tools just from from this window. So if you will click the right mouse button, there is an option to capture node screenshot. So then any node you're able to download as an image. So I downloaded each of these items, let's say, and I use them as a PNG. I downloaded as a PNG. But then I also found that, OK, maybe the PNG is not the best format to use, because right now, actually, we have much better formats like WebP or others. So the next thing I did, I converted the PNG to WebP. I used this kind of converter because I only had a few images. But actually, if you will have much more, then you can use any, let's say, more a tool that allows you to automate this process like this one. This is a Node.js tool that allows you to convert at once multiple images. And I want to show you that even visually, I was able to see the difference. So I had the same, let's say, functionality, but even if I refresh the page, you can see that the thumbs appeared immediately. And yeah, also I applied lazy loading. I set both dimensions. And yeah, I formatted this to the much, let's say, a lighter version than before. So next tip and next my learning, compress and optimize images. And next thing I did also was connected to this YouTube player. So I noticed that this carousel also can cause some shifting, because before I selected any, let's say, video, then it was everything is moving down. And I decided also to create a placeholder for this player. And what I did, I just created this kind of placeholder as an image, also very light, also compressed, so you can see that also the, let's say, the use and feel is much better than before. Next tip, next learning, reserve space for HTML elements by adding placeholders. And the last thing I did, it was related to fonts. So I preloaded the critical font, and also I used this font display option to optional. And also next learning and next tip. And I did measurements. I did in the same conditions. It's very important. And you can find that everything was in green zone. But I want to, this is a perfect moment for photos. Photo, because there's everything on the one slide. But I want to tell that, OK, I improved my, let's say, the values and core web vitals. But I think the most important for me that this tips works. And so basically, even me from a user side, I was able to see that, OK, I improved. I could see the performance improvements. Also that the layout was more stable. And I want to tell you that I think from developer side, it's good to know which exactly changes can help you to improve these aspects. Not think only about numbers, because numbers can change in the future, because engineers are still working on these APIs. So I would say that, yeah, it's nice to find direction in which you should improve, let's say, your development, than only count the numbers. And that's all from my side. I hope you learned at least something new, at least one thing new. And it was a pleasure to be here, and yeah, enjoy your conference.
Thank you so much for this amazing talk. I've learned already a couple of things here. I want to apply some of these learnings. And can I once again ask you for another applause to Marta, because when you are a speaker and you have technical difficulties like starting, it basically triggers a panic attack, and Marta did amazing still after the technical difficulties, so applause to her, please. Okay, so we have our next speaker setting up. Our next speaker, Mateus. I was thinking as well, debating on how I would introduce Mateus. I could introduce him as the person who did talks that generated most imposter syndrome on me. Every time I see a talk from Mateus, I leave there like feeling like I know jack shit. And I also thought about the other thing, which was the story of how I met Mateus. Because I was in this conference in India, I didn't know anyone, and suddenly I hear someone speaking Portuguese. And I was like, oh crap, that's my friend now. I'm going to hang out with this dude because now I have someone who I can talk with. And that was Mateus. So Mateus is a senior front-end engineer at Medallia. He's also further ado, a huge applause to Mateus.
All good? Cool. Olá Coimbra, sou Matheus, muito feliz de estar aqui. And that's all the Portuguese I got for now. So, yeah, we're here to discuss some speed at scale. This is me. By the way, you can find me everywhere as White Combinator. I am a senior software engineer in Medallia. I'm part of React Summit NYC committee and GD in web technologies. Before we start, I want you to know a little bit more about this session, but I want to know more about you. So can we raise your hands here? Who's here working with front-end? Okay, the vast majority, great. And with React? Okay, kind of half of you, I guess. So the post that motivated this session, it's called Silent Engineers. And there's one quote I love about this post. It starts like, while browsing Hacker News, I sometimes get a feeling that every developer out there is working for a fan, as there are always posts from those people doing some hype stuff. And he goes on. But let's be straight, that's like 1% of all developers out there. The rest of them are just lurking in code with their language of choice and being happy with it, be it Fortran, COBOL, Perl, PHP, Java, whatever. So this talk is not about, unfortunately, not about the state-of-the-art things on Solid. You've had plenty of them, or Astro, or others. I myself also have a session about this, but this talk is about web performance and realities of your industry, our industry. So there's this very famous meme on web performance that web performance is just simple as drawing a horse. You just got to do these 4 basic steps, and then just figure out some tiny details, and you're good to go. It's supposed to be fun. And so that you know about the industry I'm talking about, so I work for this company called Medallia, which is a customer/employee experience company, more specifically in the survey team. So imagine anything you get when you go to a bank, when you buy something at a store, etc. And this talk is about this project and how we modernized dependencies, how we did code splitting, how we did React, how we managed to do all of this while targeting different browsers, but also about some challenges you might face in legacy code bases, our experiences, what we have in our radar, and some lessons learned along the way. So better rush. So the first part, modernizing dependencies. So when I talk legacy systems, I'm talking this kind of thing. So I don't know if you in the back can see it, but React 15, Node 10, first version of Webpack, and etc. So let's start with Webpack, right? Because we had a long way out to Webpack 5. You've probably seen a lot of cases, or maybe at your companies, you've seen how people improve performance by using Webpack 5 and all of the fancy things it has with caching, proper tree shaking, and all of that. But the other side of it is migrating, especially if you're in the first version, can be tough. So you'll find a lot of conflicts amongst your dependencies and your loaders and all of that. Not to mention that a lot of APIs, they're changing from one major to another. So the gotchas we have here is that, first one, migration is about having all of your plugins and loaders not only being compatible with Webpack, the Webpack version you got, but also with each other. And that's super tricky if you got a few of them. The second thing is you cannot go to V5 from V2 or V3. So each process is an entire different process that has to be done sequentially. So try not to stay super behind. And the third thing is, for example, Webpack V5 has Node 10 as a minimal requirement, but you'll find that a lot of the loaders or plugins that you're using, they might have different requirements. So even though you're conforming to Webpack requirements, you might have to go to Node 12, 14, or 16, depending on your dependencies. So let's upgrade Node, specifically going from Node 10 to 16. I don't know if you've ever been in a similar process, but there were a few changes in the workings of VH that impacted this a lot, and more specifically, Node Fibers. So Node Fibers is a package that is behind a lot of the popular packages we have out there, and it just stopped working as of Node 14. By the way, the team from SAS, they have a really good post on this and how this process went for them. So, okay, Webpack, we're good. Node, we're good. Let's talk about React. So going from React 15, who here has done React 15, by the way, in class components and, well, half that done Webpack. So it is a common thing that when going from a major to another, you will notice some decreases in the overall bundle size. More specifically, going from 15 to 16 means a 32% cut in overall bundle size. So by updating React itself, we're sparing some extra kilobytes. But the first gotcha here is this. So we were using prop types, and prop types are part of the React package in React 15, but they're a different package in React 16. So how can you smoothly handle this? Then I thought, it was not the first time I was upgrading from React 15 to 16. Back at the time when React 16 was launched, I had to update the code base, and I even had a talk about that. And the core of the talk was JS Code Shift. Who here has heard of this thing, JS Code Shift? Okay, 3 of you, great. So the short thing is JS Code Shift is a tool that runs in transformation script over one or more JS or TS files. And there's a lot of explanation around ASTs and etc. But the lucky thing is JS Code Shift has, there are a few open source packages that work on top of it, and React Code Mod is one of them. So React Code Mod is a set of JS Code Shift transformers that are aimed at helping you upgrading your code base. And one of these code mods is the prop types thing. So you could automatically update all your prop types by running JS Code Shift. But the gotcha was, okay, how to hide all of this behind a feature flag? Because we had a lot of customers and we couldn't risk this migration to break things and etc. So it should be an opt-in mechanism. So here comes the code generation part. So just for you to have an overview, this is what we wanted to do. So in parallel, we wanted to have different versions of our developer dependencies, so Node.js, Webpack, Babel, etc. Also different versions of what was running for the client, so React itself. And also different strategies used for bundling and serving those different versions of things, so different config files, etc. It's easier if you can visualize. So before, what we had was something like this. So we had packages, and then the first package would be the core of the application itself. The second package would be where we kept our end-to-end tests, and so on. So we wanted to go from this to this. So breaking down things, so legacy A is where is the default bundle that is served if you wouldn't have this feature flag enabled. And that's where the active development of the application kept going on. So new features, bug fixing, all of that. And that's also the code that we kept tracking in the Git repo. So, and then you have the legacy dependencies. So React 15, Webpack v1, Node 10, and etc. And then we would have this Next wrapper here, not to be confused with Next, the meta framework. So under Next is everything that is hidden behind a feature flag. And we had the modern dependencies, so React 16, Webpack 5, Node 18, and all of that. I know there are other versions of React, and the 16 is not the most modern one, but it was here. And most of the things that went inside this were code transformers, automation scripts, and the new Webpack and Babel config. And also some parts of the code that we didn't manage to code generate. So some of the test files that we're using, like legacy APIs of Jest, of Enzyme, or other testing frameworks, we had to manually update these. And then within this thing, we would have the code that is generated. So we would have tons of code being generated in the CI, or you could also run them locally, and those would be our React components, the utility functions, most of the business logic, etc. And this code is never pushed. So we would also code generate a gitignore file that would have more than 1,000 lines to avoid that duplicate code was pushed to the server. So a very, yeah, maybe contrast isn't great. But basically running, you would see something like this. So you're copying files, you're moving files, you're applying transformations and all of that. Speaking of transformations, so I would really recommend you to check this tool. It's called AST Explorer, and it gives you a very, very good visibility on what your code gets translated into once it's run. And you can, for example, understand like a simple import React statement, what it's becoming. So on top of these AST explorations we did, we wrote JS code shift transformers. The anatomy of a transformer is like this. So a JS code shift transformer gets a file, and then it has a lot of functions. Here, for example, I'm finding the declarations that are called full and renaming them to bar, and then returning a new source code. So this is like hello world for it, so we would write more complex custom transformations. And the way we abstracted things were in transformers groups. So each transformer group would have a nice label to basically say what that transformer was doing. It would have a file pattern to match, so it could know which files to apply that transformation to, and also the path that would point to a JS code shift transformer that we wrote or that we were using from open source, like React Code Mod. And then all we had to do was iterate through these groups and apply the transformations to them. So that was kind of React. Another thing we also had to update was WebDriver. So WebDriver is an end-to-end testing tool. We were using it was in version 4. We went to version 7. And we had a similar problem as Webpack. So you can go from 4 to 7. So we had to go 4 to 5, 5 to 6, 6 to 7. Luckily, again, there were some code mods available, so provided by WebDriver itself. So for some of the things, it was just a matter of running this code transformer. And as they say, no more changes necessary, but again, some gotchas. So due to the way that V8 works under the hood and Node changed it and all of that, there were some of the APIs that just couldn't be migrated automatically, so they discriminated all these special cases, and we had to manually fix them. So that was it for modernizing dependency. Another thing we did was code splitting with dynamic imports. So you're probably familiar with this. So basically, we had a few very, very large chunks of code that were not necessary for some surveys we had. So split them in different things. If you're familiar with React, you can do this with React Lazy and Suspense that are available as of React 16. And we got some cool results. So the baseline got way smaller, and then depending on the types of questions you would have in a survey, they would be downloaded afterwards. So you would download only the necessary kinds of questions that are being used at your current survey. But just like any other performance optimization, these are not always for free. So we had a few gotchas. I guess the highlight was because we allow customers to write some custom code to run in their surveys, like JavaScript, CSS, we had to watch out for the code that was being dynamically loaded because they were trying to customize code that wasn't loaded yet. So we had to revisit this. Third thing, Preact. Has anyone ever heard of Preact or used? Okay, quite a few hands. So for those who are not familiar, Preact is this lighter alternative of React that has like about 10%, has a way smaller bundle size. So we also managed to adopt Preact by allying our production builds to Preact and its compatibility layer. So by doing so, we also got a few extra kilobytes, going from 205 to 175, again, with gotchas. So some of the Preact issues, they were exacerbated when combining Preact with Suspense and React Lazy. So the performance trade-off we did was to replace React and Suspense and Lazy for the old way of doing dynamic imports in React that is loadable components. Wow. So part 4 is how we shipped all of this while maintaining compatibility. So I don't know about you, but it's not often that we check which browsers are visiting our apps. But you would be surprised, depending on the scale and your markets, that people out there still use Nokia browsers or Blackberries or Internet Explorer. So you should ship polyfills, but at the same time, you should watch out for Lighthouse, because you might be sending unnecessary polyfills to modern browsers. So revisiting these strategies we got for polyfilling, the first one is polyfill.io. So polyfill.io is a very, very popular service that basically it's going to inspect the user agents of your browser and send us the polyfills that are targeted at that browser. And it also has a very, very nice UI that you can pick some specific polyfills. As a third-party script, you might be adding some extra milliseconds setting up the connection to their server and etc. And one thing to know is, depending on your SLAs, because it's a third-party thing, you're also subject, in the unlikely event that they would have some outage, that probably means an outage of your product too. Okay, so second option was the Babel plugin preset. So preset, you have an option called use built-ins, and you have two available values for use built-ins. The first one is use built-ins entry, but the trick here is that it's not really super useful if you're targeting very old browsers like Explorer. And the thing is, it might remove some polyfills, but most of them are going to be bundled and still downloaded by everyone. And then you have the other options, that is use built-ins usage. So the trick here is that it's not adding polyfills for your dependencies unless you're piping your dependencies, like your node modules, through Babel. So that might be a problem. And the second thing is, it's not very smart in the sense that, for example, if you got array.includes, it's also going to add a polyfill for string.includes. And if you got symbol.toString tag, you're going to get polyfills for anything that's called toString tag too. So third option is what's called differential serving. So there are a few different ways that you can do differential serving. One of them is by leveraging the no module / module thing that browsers have. So the way you split is, if you don't have ES6 support in a browser, like Internet Explorer, it won't load anything that's called type module, the scripts that are tagged as type module, and it will load the no module ones. And you can use no module to serve the polyfills for the browsers that need them. So it basically looks like this. You add script, no module, and then you serve the bigger version, and then you got script type module, and then you serve what's targeted at modern browsers. So summing up, you got polyfill.io that is easy and doesn't ship anything to modern browsers, but it might increase some core web vitals like TTI and FCP, because again, it's a third-party thing. You got use built-ins from Babel preset that is easy to set up, but it's either not very useful for old browsers, or it's going to require you to pipe your node modules through Babel. And then you got the no module versus module thing that is easy, and it has wide support, but it's only going to cover ES6 versus non-ES6 polyfilling, which was good for us. And then you have different ways to apply this thing. So you have just using raw module, no module distinction, but then you're going to see that there are some inconsistencies across browsers. So for example, you might end up in scenarios where both scripts are going to be downloaded and executed, or both of them are going to be downloaded, but just one executed. So there are a few inconsistencies you would have to handle. The second way is you can leverage user agent detection. So basically, this can be your expert Node.js server, Java server, whatever. But the trick is, and that was our scenario, you might not be in control of the server, and that was our case. So the server that was serving this React application was owned by an entire different team, and they didn't want the complexity of adding user agent detection to do our purpose. Also, depending on how you load it, you're missing some of the benefits that you have from script type module. And the last thing you have is runtime detection. So you can basically add another script tag that is going to detect whether this browser is compatible with module versus no module thing and insert the right version. So summing up, this is what we had. So out of the available polyfilling options, we went with module versus no module. And out of the different ways of serving these different modules, we went with the runtime detection. So that's the summary. Some results we got. So first, we got a lot of huge pull requests that took a lot of time to review because they were basically touching hundreds and hundreds of files and hundreds of thousands of lines. But unit tests and also our end-to-end tests were passing at the end. In terms of bundle numbers and button footprint, so we ended up with two. If you were to adopt this new feature flag, you would have two bundles. The modern bundle had a 37% cut, going from 279 to 176. And the legacy bundle that is served to the legacy browsers would be 25% smaller. So in numbers, this means the ones that do support module and the ones that do not. As of yesterday, that meant almost 97% of browsers worldwide. And for us, this was our cut, so only 0.2% of customers the ones using Internet Explorer would get the bigger bundle. Speaking of Core Web Vitals, most of them improved. So we got a 6-second faster FCP, 3.5% faster speed index, 2.4 seconds faster LCP, and 2 seconds faster TTI. Other metrics also did improve, so timings, those are coming from web-based tests, so you can see when the feature flag is on versus when it's off, and all of these improved. Overall visual progress, that is basically how faster your users are going to get the content of your app and etc., also improved. Oof. So there's still a couple of things we have under our radar. First, overall, culture and tooling can always be improved. So, for example, checking things like bundle phobia before you add another library to your project, or using some VS Code extension that is going to flag the bundle size and etc., or using dev tools to figure out some unused bytes of the code that you're loading. Not to mention new tools like Medium.js. They are working on maybe beta version of their plugin for VS Code that is going to spot possible enhancements for your React app. Also, offloading third-party scripts with something like Parentown by Builder.io is also something we have in our radar. Using different compressions algorithms other than just plain zip. So nowadays we got Broadly, Zofly, Z-Standard, Guetzli, and many options for better compression of text, of images, etc. Not to mention things like Quick, part of the HTTP-free spec that can cut off a lot of time on round trips. So literally on the front and on the back, there are a lot of things that can still be improved, not to mention an ever-living culture process. So a few closing thoughts before you're free to go for a coffee. I always insist that sometimes understanding the internal of certain tools or of your language or whatever you're using might help you create your own abstractions. And I think that this case that I could briefly surface is one example. So leveraging AST Explorer, understanding the AST of our React code and writing transformers that would refactor our code for us and allow us to ship both legacy and modern code that is toggleable via feature flag is one really good example of it. Not to mention, have you ever heard of Elm or PureScript? Yeah, very few hands. So these were efforts in the past in the front-end realm that really pushed to optimize performance or how safe your code is and this kind of thing. And they had a huge, huge compiler basis behind them. We also have recent efforts. So what Svelte does with its compiler, or the thing we knew as React Forget, and it's now officially the React Optimization Compiler, and etc. So I think that these are really poster boys of how internals can help you with your day-to-day job. Second thing is, and about polyfills, is you probably have to ship polyfills for all the browsers your users might use, but at the same time, it might be a bad idea to ship all of them in a preemptive way, just thinking of what's theoretically possible. So do think of the trade-offs around there. The other thing is, do not take fast networks, fast CPUs, memory run, and all of this for granted, because it might not be there. So it's really key that you test on real devices and real networks, and that you have them in mind. And there are a lot of very, very interesting reports on quality of connection and quality of devices around the globe. This performance inequality gap is a really good one regarding last year. The cliche is true, so as always, there's no silver bullet. These were things that worked in our very specific case. Some of the things that work for us might not work for you, and vice versa. So it's really important that you identify what are the key metrics for your product, your business. And speaking of business, it is really key that as much as you can, you try to correlate performance metrics and whatever you see on Lighthouse and other auditing tools to your business metrics, because at the end of the day, these are the ones that matter the most. The slides for this session and other sessions I got on internals of tools, on web performance, and a lot of other things that are available there. I'm going to be around for the rest of the day, and muito obrigado.
Wow, what a great talk. There was a lot of stuff to process here. I'm pretty sure I would want to go watch the recording afterwards. Now we're going to have a break until 3:10. Then we'll be back with Alien. After Alien, we're going to have like a panel about the 3:10, and we're getting ready for the next couple of sessions and panel. Ooh, thank you for the excitement. I appreciate that. You're the man. Okay, so what was I going to say? Oh, I need to introduce our next speaker. But before I introduce our next speaker, I just want to talk a bit more about the slot that we're in right now. This is a bit more about frameworks. Our next speaker works at this thing called Astro. Has anyone here used Astro? Okay, there's some people here. Oh, the speaker used Astro. Okay, that's amazing. And after Elian finishes, we're going to start the Future of JS Frameworks panel. I can already give a spoiler. During the panel, there's going to be a giveaway. There's this book that one of our speakers, Tejas, wrote that's called Fluent React. I can safely say that this is one of the best React books I read in my life. It's not because my name is in the front page here, but it's really, really, really good book. So during the discussion room, we're doing the giveaway. And after we finish the discussion room, there's going to be a book signing. So Tejas will sign your books if you so desire. So without any further ado, because it's time to bring him on stage, our next speaker is part of Astro Core. He's the person who introduced me to Astro. He's coming all the way, I would say from Brussels, but he actually is coming all the way from Canada because of flying. But what can I say about Elian? He's not an alien. No, he's a very, very smiley person. He always has a good mood. He loves beers, so you'll probably see him on the after party having a couple of beers. And he's going to tell you all the things Astro. So without any further ado, welcome Elian van Kutsen.
All right. How's everybody doing after the break? Doing good? Woo! All right, good. So obviously, all things Astro. Who am I? Well, I'm Elian. I, of course, work on the Astro core. I work mainly in the DX team and UI teams of Astro. I organize React conferences in Brussels, BGS, and Paris, and soon want to come in Africa. So that's really exciting. I also organize meetups in my hometown in Ghent in Belgium. So if anyone from Belgium here? Probably not, right? Yeah, sad. Well, of course, you're not here for me, you're here for Astro. So let's dive into Astro. So who had used Astro? Show hands, show hands. Okay, cool. Most of them are my friends, cool. No, that's totally fine, because I'm here to tell you more about it. So we like to see ourselves as the framework for content-driven websites or web applications. Content-driven doesn't necessarily mean only your blog. It's way, way more, but we'll get into that further. Think of it as being a meta framework, like Next or Next. So the syntax is super familiar. If you ever use React or any JSX-like framework, this is probably very familiar to you, except that in the front matter there, like the code fences at the top, that's where you use your plain JavaScript or TypeScript. You can choose whatever you want, and then below that, you can use all those components you imported or those variables, basically a JSX-like framework. Now, this exactly is the code of my homepage of my own website. So you see how super simple it is, and then, of course, you have the beautiful design. Oh, isn't that pretty? Well, a lot of people disagree, but you might not like it. This is what peak app design looks like. Cool. This you understand. So what makes us different than Nuxt or Next? Well, we ship with 0 kilobytes of JavaScript in production by default. I'll explain that a bit further. So think of your app in a meta framework, Nuxt, Next, whatever. It looks like this. We require a lot of JavaScript to render all of those components. For instance, like the header there, the text body, the image slider, that might make sense to render with JavaScript. But why are we rendering that footer here with JavaScript? It's just static links. That doesn't make sense. So by default, Astro will just compile it all down to native HTML and CSS and ship that to your production. Super fast for your users. So, of course, Lighthouse 800 out of the box. So that's why we call it ideal for content-driven, because content, in a sense, is always static. Now, I hear you thinking, but I want like some interactive experience, of course. What if I need interactivity? What if I need buttons to work? Well, we have client directives for those. This is how they work. It's very simple. So you use client load on a component. It will ship JavaScript for that component only to your production whenever it's happened to be there.
client idle does exactly the same, but only when the main browser thread is idle. Makes sense. Client media, for instance, for buttons, mobile menu, think of that. Whenever you see a button on mobile, only hydrate it when it's actually on a mobile device. Otherwise, it has no use. Client only is just basically skipping out of our compiler. You know what you're doing, and you don't trust us with your code. Totally fine. So we have this static application, but with some minor tweaks, we can have it like this in Astro, where we only require JavaScript in the components that actually need it. Now, of course, Astro is also open source. So you can totally build and extend your own client directives. For instance, Ben, one of my colleagues at Astro, built client when it's rainy in New York. So can you guess what this does? It only hydrates your component in production whenever it's raining in New York. So that's pretty cool. I didn't build this because in Brussels it's just always raining, so that would be useless. Cool, we call this architecture the island architecture. And it comes with a massive advantage, and that is you can bring your own framework to it. So imagine you have a Svelte component and you want to use it in Astro, you totally can. You have a Vue component, you can totally use it, or you bring something else, you can totally do that. That's fine. We don't judge you for it. I wouldn't recommend it, but you can do it. Like this is good for migrations, for example. Super handy. But still, if you don't use that client directive, it will still compile down to native HTML. So in that case, Astro is one of the fastest frameworks out there. I know that over the last year, I don't know who has followed it, but we have done a couple of releases, quite big ones. So yeah, a lot of people were laughing with us because we release so often. Yeah, I'm sorry about that, we just cheap code. So we launched Astro 2 quite a while ago, and the major feature there was content collections. Content collections offer this amazing API and very native feel of working with your markdown content. You can basically have it completely be type safe. We'll give you rendering errors whenever you miss something in the front matter. It's very easy and, of course, fully type safe. We use Zod for that, which I think Tejas showed it earlier as well. So it's really handy. One of the things that also excited me very much is hybrid rendering. Hybrid rendering is when you have, for instance, a full static application, but you need one API endpoint. Yeah, that doesn't mean that you want your whole website to be server rendered. You just want one API endpoint. You can totally do that with hybrid rendering. Or the other way around, maybe you want just one static path and everything else to be server-side rendered. You can totally do that. That's fine. We don't judge you. Astro 3, the major feature there, view transitions. Astro was the first framework to stably ship view transitions, and it's such an amazing experience. For instance, this application, you can see it switching pages, and it's actually an MPA app. It's amazing to see, like this almost feels like an SPA, but still is an MPA, which is amazing. And the best thing about all of it, it's only 2 lines of code, which is pretty incredible to me. Now, the cool thing is, in the next Chrome version, I think it's 126, view transitions are changing a bit since they are adding MPA support natively to the browser, and it will look a little bit differently. It will look like this, and you do it actually in CSS instead of in JavaScript, which is really exciting to me. Now, of course, image optimizing, we heard it from Marta earlier. If you want good CLS, for instance, yeah, you need some images to be optimized. Good thing is that we do it out of the box for you. So you provide us the PNG, you put it in the Astro Assets image component, it will automatically compile it to a WebP image optimized for the web. Not only that, but it also works with picture. And what is amazing about picture is that you can actually have different outputs formats. For instance, you want one in AVIF and one in WebP, depending on which one the browser supports, you select the best one. Super cool stuff. Page partials, really cool. It's basically, you can totally get rid of the HTML tag, the body tag, the head tag. So what you can do is actually just use it with HTMX and hot swap your HTML. Really cool stuff. Starlight. Anyone heard or used Starlight? Yeah, it's less known, but it's really good. It's really cool. Starlight is this documentation generator built on Astro, and it's super fast. You can use, basically think of it like a Docusaurus, but then for a better framework. And of course, you get to use all the goodies that Astro provides. So island architecture, React components, whatever you want. And actually, tomorrow is its very first birthday. So yeah, congrats, Starlight. Cool. Getting to the end of the quick thing, because I need to do a demo afterwards. Astro 4, the dev toolbar. super cool stuff that we have done with this. So inside of your browser, you just have a dev toolbar. You can click on it. This is the inspect tool, and you can instantly see where your client components are, what the props are, what location it is, what framework it is. It's super useful, and all without leaving the browser. Really useful. But also, we have an audit tool. So again, we heard about good DX and like good engineering, accessibility. Well, we provide those for you. You can see, oh, I'm missing an area attribute here. Let's add it. Or maybe, oh, this image isn't optimized. Maybe let's do that. Or lazy loading. Oh, you're forgetting it? Let's do that. But also, open source first, you can totally build your own one to extend the dev toolbar. So you can build it. All right, and then we have a couple of experimental features. And we have content collection caching, which is totally new. We're still experimenting with it. But we have a docs code base in Starlight of around 4,000 pages, which is really a lot. So if you build that in CI, it takes quite some time. But with content collection caching, we actually only rebuild the pages that actually have changed. Everything else just stays in the cache. And with that, we were able to have like an 80% gain on all of our build pipelines, which is really, really crazy. Of course, we also redesigned our own documentation to be like this, which uses Starlight, which is really good because now Starlight gets to benefit from the features that Astro needs and vice versa, which is really useful. Of course, that's not everything. We have way more than I have time to cover. But what's next is one of the questions I get most. And my answer is always, hey, we have an open roadmap, so you can decide. You can basically add a discussion, you can open an issue, you can open a PR to actually start and help contribute in Astro. And we really appreciate those, so don't be scared if you have an ID for Astro. We totally want you to. Cool. Has anyone heard of a new project called AstroDB? Whoa. Oh, not that many. OK, that's good. I'm going to show you some magic. So AstroDB. AstroDB is the native database layer platform for content-driven websites, aka for Astro. And you can totally build authentication into your website, or you want some comments to your blog. You can totally build those natively with the first-party API inside of Astro. Best of it is it's super generous. We have a free tier that is actually very, very generous. So that's really cool. Next to that, just the database, it also has some apps. For instance, here you can see those. For now, it's still in beta, so it's still very simple. We have the SQL console, which is basically just an SQL console where you can just give in your command, see the output. It's useful, but nothing too special. One that I want to talk about is web vitals. You can totally monitor real-time your web vitals from AstroDB. For that, we actually use exactly the same API that Marta showed earlier. So it's really handy. It just puts all of it in your database. It reads them out like this, but you can also do or build your own dashboard if you want. Cool. Ready for some demos? Yeah. No? OK. Let me quickly. Why am I seeing this? Yes, perfect. Got to share my screen here. Give me a minute. Main display. Nope, that's totally the wrong one. Huh? Yes, that's it. All right, is this big enough for y'all to read? Big enough? Good, OK, thank you. So what I've built is very simple. It's basically this page. Hello, JNation. It's some kind of a guest book. So it just says what people are saying and then a comment. For that, we're going to use a form that says, post your own comment, and then you have just a very simple form that has a name, a title, a comment, and a post button. So I'm going to show you how you can actually build that with AstroDB and some other cool stuff. First of all, in our DB, we want to actually represent the comment model. So let's do that. So let me make a comment. Comment equals define a table. That makes sense. And we want some columns in that. And what did we see? We saw a title. That's probably a string. So let me add column. There it is. Dot text. Then we want a body. Sounds good. Created that. That's actually a really useful one. Let's do that. But also we need a name. Column dot text. All right. But also in this created ad, we probably want that to be automatically filled with a default. So let's do default, and not now, but now that we import from AstroDB, which will be the local server time of the server. That makes sense. So let's import that in our actual tables. So we now have a comment in our database. Cool. Let me start the dev server here so that we can actually use something. OK, cool. Next up, we have seeding. Anyone is probably familiar with seeding, so let's do that. So await, database, insert into the comment section with some values that we make. Title, let's do hello. Let's do JNation. JNation. Name, of course, I am Alien, so let's do that. And then the body, this is a comment. Good enough for me. So let's import that quickly as well. It's not there, so let me do it here. You import it actually from AstroDB, not from the collection. So now we still have this being static. So what if we actually want to use our data? Because this technically is inside of our database. So let me get that out. So in our index, which is just basically the index page that we saw earlier, we have this. So we probably want to add our comments there and map that. So let's do that. Oops. So const, let's get the comments. So let's await, because you can use top-level await. Select all from comment. That's it. But maybe we want to order them. That would make sense, right? So order by, let's do descending on the comment, oops, dot created at. That makes sense. That's super easy, right? Thank you, Drizzle. So what we now just want to do is very simple. We just want to do comments, dot map, comment, and then we just want to copy paste this in. Oops, thank you. Let's get rid of that. And actually, that should be typed. Did I do something wrong? That should work. Comment dot, let's do title here. What was it? Name, created ad, that seems good. Likes, let's integrate likes as well later. Let's do it like this, 0 likes. Cool. Now, if we restart the dev server, because we have to do that, sadly enough, and now it should say, it doesn't say it. Did I do something wrong? I don't think so. Well, it should work. Damn it. Oh, there it is. OK. I did something wrong. No, that's not worth applauding for. But yes, this works. But now, of course, we want to actually post a comment. So that would make sense. So for that, I've built this post page. And the post page is actually really easy. So let me go to the post. No. Yes, post.astro. So we have a form here. But that form, probably you want to use an API point. Well, not really, because you don't want people outside of this form to post comments. You don't want to expose that API. So we're going to use something called Astro Actions. It's still highly experimental, so very much might fail. Let's just hope it doesn't. In this case, I'm going to use Solid because I love Solid. So let me do form.tsx. And it's really easy because I'm just going to do export default function form, and then open the function and return exactly the HTML that we had before. Oops. Copy that over, plug it in here, save it, and now we can do form, and let's client idle that. That makes sense. And now import form from components / form, not .astro, but just form. And let's see if that works. Cannot find form. It should. Why don't you work? What? From? That's right. Left, left, right, left. I can't hear you. Be louder. I see it. Yeah, I see it. I see it. Thank you so much for helping. Yeah. But now, actually, you applauded already too early, because this is actually the solid component that's displaying there, and I didn't have anything to do with that. So that's really cool. What we now want to do is, have any one of you worked with forms? Probably you have. So if you submit a form, it actually always does an action that is a get page. And we don't want to do that. We actually want to do something different. So what we're going to do is make a function here that's a onSubmit. And then let's make that an async function. And whoop. Is that everything? Nope, I'm missing one. Perfect. And then ae.preventDefault. No Copilot, that's not what I'm about to do. Prevent default. So now we can actually input the data, and it will stop it from doing a get. Cool. Now, let's go to the actions. So what are actions? I'm going to explain to you. It's very easy. So what we want an input. And that input is just a Zod validator object. So let me import Zod from the actions. So let's take an object in. And in that object, we already know that we have a title, body, and a name. So that's easy enough. Now, what we also want to do is we are submitting a form. So let's do accept the form. Oops. Yeah, again. OK, cool. So now we have that. Now we actually want to do something with that data. So let's import that. So title, we have a body, and we have a name. Cool. Now we just want to very simply do await database.insert in comment, indeed, and then the values are basically the object itself, so title, body, and name, but I think it's comment. That's the body. And then import the database from this one. Cool. Did we not action comment? Comment. Cool. Did I do something wrong again? Yes, it's probably body equals body. Let me quickly check the form how I called it. Thank you, Tejas, for your very helpful comments. OK, that looks good to me. Body, config. Yep, OK, looking good. So now in the form, let's do await actions dot, and then we know comment. Really easy. Now we have something to insert there. We know that was the form data, so let's get the form data. So const form data equals new form data from e.target. That will error in TypeScript, but of course we have as, and that's HTML form element. That should be everything, and then let's get the form data in there. Cool. And then maybe we want to navigate again to, I'm going to quickly do it like this location because I have 5 minutes left. .href equals /. Cool. Simply enough, right? So let's test it. John, hello world, test. Will it work? Nope. That was very good. Cool, we have a bad request, invalid type, expected the string path body. So we know that something is wrong with the body. I already thought so that I did something wrong. OK, so in the thing we have comment, that's it. So we need to go back to our thing, and we're expecting comment here. That's why I made a mistake in the beginning. So body is actually comment. Easy enough to debug. So John, hello world, test. And now it actually works with an action. Now, thank you. Now let's do something even crazier. What if you want likes? Like your whole website is static, but you want some blog posts to be liked. You don't want to expose an endpoint, you don't want to server render everything. So what we're going to do is just make one button that has likes. And for that, I'm going to alter actually the whole thing. So likes, I want likes now. And that's a number by default 0. That makes sense. In the post itself, oops, in the index page, if I can find that, we have 0 likes here. So let's make that, see how type safe this is. This is really awesome. So comment dot, and now we have not likes, likes. Yep, restarted the server, sorry. Likes. And now we see, again, 0 likes. You see that the other one is gone, since that wasn't seeded, but this one was. Now, of course, we want this to make a button. So we're going to make a form component, like, ooh, I'm going to rush against the clock here. Let me check if I can do it. So do it again, export default function, like, perfect. Then we're going to return a, let's do a button, and then call it like. With the actual likes, let me create a state for that, it might be better. So const like, set likes, use state. Nope, we're going to create a signal here, because we love signals, don't we, Attila? Yes, perfect. So let's show the likes here. This is a likes, oops, like this. OK, amazing. So create single, let's take an initial state here. Initial state, and let's take an ID. Perfect. So let's do here the initial state. Let's do it like this as well, so that we have initial state equals a number. And we have the ID. Let's also make that a number. But if we actually want to get the ID, yes, type button Cool. Good enough. Now set likes, that's not important yet. Create signal, yep, that all sounds good. So what we now want to do is actually replace this to be that like component, like, and then client idle it. And of course, we know that we have to pass some structures here. So what are we going to do? Well, we're going to pass the initial state, which is the comment.likes, and the ID, which is the comment.id. And we actually don't have that yet, so let's add the ID to a config. So let's add an ID, let's make that a number, and let's make that the primary key. That makes sense. True. Perfect. All right, so that should work. Now we want to update that, of course. Let's also import the like component. That makes sense. Import like from components like. Whoops. That's it. Perfect. Now, the action. How are we going to process the action? So we have it here. Let's take an input, which is a z.object. Makes sense enough. And in that input action, we want the ID, which is the number. So we have the ID here. So what we want to do is await the database and select from the comment where, let's import equals, comment, I'm going to have to import it. Oh, it's already there, fine. Select, whoops, from comment, where equals comment.id is the actual ID. And let's get that one. Cool. So we have to const get comment, I'm going to call it. Cool. Now we want to update that comment to be updated. So const updated comment equals await database dot update comment set. Ooh, 25 seconds left. Ooh, that's going to be very, very hard to do. Likes equals likes. Oh, get comment dot likes plus 1. Yep. I hear the alarm. Give me 1 second. It can be undefined. Yeah, whatever. It won't be. OK. We have that. Now, very quickly, let's just add the action in. Let's add the action very quick. So let's do onClick equals, and then just await, whoops, async, await, actions dot like, and then we just pass in the ID. And that's basically it. Now, I'm not going to do the pass since I'm over time, but what it will do, it will update the state, then you do the update state, and you're done. And it will actually be in the database. So yeah, it's a cool thing. Said I can't show you the pass, but actually here, you see that the action thing isn't returning anything. Cool, very fast, whoop, whoop, whoop. Want to stay updated? These are some links, astro.build, astro the chat. That's our Discord server where you can find all updates. We chat there. You're all very welcome to join there. Thank you so much, and hope to see you next.
Okay. Is this microphone working? This one? Can you hear me in the back? Yes. Okay, cool. So now I'm just going to ask for
I guess I stay on stage.
Set up the stairs. The chairs. I'm going to leave Alien here because he's not going anywhere. We're just going to go getting stuff. I'm going to ask also our speakers to come on stage. So Attila, Tejas, and Mateus, please come on stage. And okay. Let's do this in a semicircle, just to make sure, so we spread them a bit. This is logistics. We are trying
to sit in order?
Center a div or something like here. You can sit however you want.
Yeah, let's sit in order.
Can you just bring me one more chair?
Like we're very organized people.
Okay.
I hope that this microphone.
Okay. So, wait. You're hearing me here, you cannot hear me there. So you already have your microphone.
Yes, I have.
One of you who wants to get the microphone first. You guys are going to have to share a microphone.
You slapping me?
And sorry I'm turning my back on you. We're just setting up the logistics while this is starting. Mateus gets the microphone first. Okay. Thank you so much. So now we're going to start our panel. And this panel is going to be about the future of JS frameworks. And when we were planning this panel, okay, that's a weird word. When we were planning this panel, I was thinking, okay, who can we bring here? And, well, you already met all of these speakers. So Tejas, he wrote the book on Fluent React. Who are we going to give away during this panel and after the panel? And you can get a signing from him as well, because then we're going to roll a table there, and he's just going to do autographs. Don't ask him to draw stuff, or you can ask him, whatever.
I'll draw
so
stuff.
Tejas wrote the book on React. We have Mateus, who is probably one of the most knowledgeable people about React, aside from the core team that I know, which is really good. We have Attila, who's part of the solid JS DX team, and we have Elian, who is Astro Core. So, I'm going to open this panel first with a question from my own, and then when we finish the topic for the first question, I'm going to ask you in the audience if you want to ask a question. So when I ask you if you want to ask a question, please raise your hand, and your volunteers will bring you a microphone so that we here can hear you. So, let's start this thing with a very generic question, and just picking from the title of this. So, what is the future of JavaScript frameworks?
Well,
what's the start with this very open question?
Fine, I have the mic. It's interesting because there's a great talk by the great Jeremy Keith. You guys heard about? Have you all heard about Jeremy Keith? If you haven't heard about Jeremy Keith, look him up. He's Adactio, A-D-A-C-T-I-O, on social media. And he, in one of his talks, he mentioned a great concept called pace layers, where as things get more mature, they move slower. Think about HTML, right? A development from 20 years ago is a development from today. And it has more capabilities, but fundamentally it doesn't change very much because it now has like businesses, companies, people's lives built on top of it. And so it's kind of important that these things move slow. JavaScript is very similar. I think React and sort of reactive interactive applications have been around long enough. React is 11 years old, and React moves slow. I think the future of JS frameworks, I'm assuming you mean for user interfaces specifically, that I think we're already seeing convergence, right? Everybody's using signals except React, and I'm sure we'll hear about that. But React is also, they're all just moving very slow, and they're sort of differentiating on smaller details, but I think we all kind of agree that reactivity looks like this, and some use JSX, and some use single file components. There's patterns that many of us are familiar with, and so I'd say the future looks comfortable, unless something radical comes along and changes everything. But then the question is, do we need that change? So to me, the future looks, I can't believe it, I'm saying this in JavaScript, but somewhat stable. Yeah.
Wow.
Hot take.
It's working.
Wow. Mic check, mic check. I feel like we'll be probably more than ever revisiting and recapping existing stuff from the past. It's kind of like, I had a session about it like the other day, but for example, there's this tweet by Dan Abramov from core team of React, where he links to a post from the Marco core team. Marco is a framework by eBay that was open source back in 2014. And this tweet is basically showing how a lot of the ideas, the great ideas the community has on streaming and all of that got popular from 2020, 2021 onwards. Marco was doing these back in 2014. And if you check that post from Marco, they're actually linking to another post from the .NET community from 2005 about streaming and partially rendering HTML and etc. So this is one example. I feel like things around compilers too. So the React community has this ongoing effort around compilers and the React optimization compiler, but Svelte was doing this a little before. And then if we go back, like I mentioned Elm in my session, but even before that, we have some efforts that never got super popular, I guess, but they were doing back in 2005, 2006, 2008, using some compiler technology to slice server and client code. So I feel like we'll see things cycling back with more and more ideas, but also we'll be more critical around what's just lost art from the past or what was perhaps a bad idea and that we should not reuse. I also think we'll have more and more heated discussions on things like hydration, for example. So we'll be discussing, like, people will come up with new ways of addressing the issues of hydration. So we got partial hydration, we got islands, we got whole different approaches like resumability. So we'll be revisiting the challenges of hydration, the challenges of SSR. I think that we'll be talking a lot about whether we want to do, like, whether SPAs were a good idea to begin with, and whether, like, multi-page apps, single-page apps, and this kind of thing. So, yeah, I feel like I've been talking a lot.
Okay, so I'm going to be the weird one and start the discussion. So I think that the choice about which framework to use is going to become more and more niche going forward, because we have, like, a framework as big as React that, given the amount, the size of the community, it's not going anywhere for the foreseeable future. There's no chance in hell we cannot have nobody getting that upset with React to refactor all their code bases and something happens. It's not going to implode. And truth is, the state of modern frameworks are good enough. If you choose one and you know how it works, you can build good enough applications with them, most cases. But then you get the kind of niche thing where, like, for example, you have this no-build movement with the Rails guy, and then you have, the creator of Svelte gave an interview the other day saying people pick their framework based on vibes. Like, I don't particularly know what that means, but yeah, like, I think everybody has their own definition of what it is, and I don't know. Then you also have, as Mateus just said, there's going to be a lot of heated discussion about some very specific topics. Like, there was some propaganda war about benchmarking and people using some benchmarking to show how this or that was doing great, and then they would look, oh no, but actually that's, you're not actually measuring what you're saying you're measuring, and then you go back and forth and trying to establish what is a good benchmark, and so on. So there's going to be a lot of discussions about that, and because there's so many frameworks and so many good frameworks, I think that's going to depend on which framework can, and it's not actually a race, it's not actually a war. I think they're going to coexist for a very, very long time. The thing, though, is it's becoming more important for people to understand how each framework works, or how the framework of choice works, to realize if they're a good choice for them or not. Like, I speak on conferences about Solid a lot, and I speak at React conferences about Solid. And then when I show some stuff about how Solid works, there are often a few group of React developers that come and say, oh my God, I didn't know I could live without that other thing, this or that. Like, the problem is not essentially React per se. Like, it's React carry this trade-off that people didn't know they were buying in. And then when they see there's a way out, they're like, okay, I'm actually a better fit that way, or this other way, and so on. So, like, there is, at this point, there's a framework for whatever you choose. If you want to build something, you don't like JSX, you have Vue, you have Svelte. If you like decorators, you have Angular, and so on. And so this depends. And each framework is going to have their own way of building stuff, and understanding how they do is going to be good enough. Like, there is a lot of talks about how the React ecosystem is so big. I think that's a double-edged sword, because the fact that it's so big, it takes a lot more effort to find the good tools that you can use, or the tools that are right for you. Meanwhile, in smaller communities, it's probably easier for you to build something that's exactly how you need, or people are actually more eager to hear your feedback and implement your solutions. And sometimes they have the right tool for the job for you. So I think it's going to be more about a case of end users picking the right tool for the job than just following a herd. And I think that's more or less the future. I don't think anything is going to go away. Nobody's going to be the React killer. Nobody's going to be the big one, whatever. it should be like a mix of everything.
I strongly agree. And I actually wanted to go in the same direction. Now, you have explained most, so I won't go that long. But no, but the thing is, it's very true that I think all of the frameworks have achieved the point that if you know the framework well enough, that you can build a performant website that has all of the web vitals, that passes Lighthouse, that's accessible. You can totally do that, like, independently of the framework. But one thing I will say, though, that I found interesting, you said you were assuming that it was about UI, about the user. I think it's actually the future of the frameworks lies more in the DX side and more in like the development experience. And I think we're seeing a very big shift there. Like when Astro came out, for instance, you saw very much like other people picking up, and it's a very good thing that moves. And I really hope that we can all strive for a better development experience, because if there is one thing that we all hate, it's debugging or not knowing where we are in our code base.
And this thing of not having a war and this kind of thing, it reminds me a lot one of the posts from Ryan Carniato, creator of Solid, last year, where like the whole core of the post is show that ideas like resumability or what React server components are trying to do, or islands and etc., they're not exactly fighting each other, but they just focus on addressing different parts of a bigger picture of problems. So there's not necessarily a war of frameworks and a war of approaches adopted by these frameworks. So, and the other thing is that I'm super on this good enough thing. For example, so my session was about addressing technical debt on a legacy code base where I couldn't find, I couldn't use Solid or Astro or whatever was the cool tag. So in the industry, a lot of times it's gonna be about finding what's good enough. And you'll notice that a lot of things like Angular are still good enough for, or React or etc.
Yeah, I want to plus one everything you all said, and I just need to emphasize this. You know, like React, recently at ReactConf announced their new React compiler, and they were saying this stuff makes React as reactive as Solid, and all of tech Twitter X, okay, if they don't come after me. All the X people lost their mind. Oh my God, no, Solid fine-grained reactivity is way faster than React. And he lost his mind. Daniel lost his mind. And we can hear his reason, but people weren't like, oh, no, this is not fine-grained reactivity. And then the React team started saying, okay, but like if you think hard enough and change what you mean by fine-grained reactivity, then we have it. And we end up like arguing about terminology that maybe matters, maybe doesn't. I will say this, and I think this is very important for all of us in this room. I had a discussion with the founder and CEO of Vercel, Guillermo Rauch, and he, you know, I asked him, I was like, look, man, your whole company is focused on making the web faster. You try like partial pre-rendering. They're doing all this stuff to like make experiences faster. And I said, why does it matter? Right? Does it even matter? Because like if I go on twitter.com, I guess now x.com/something/notifications, I will see like 18 spinners, and it's a horrible experience, but I use it. And many of us, I'm not alone here, their entire careers are all built on it, as is mine. So I was like, does it matter? And Guillermo said something really cool. He was like, yes, it's a crappy experience, but we all are addicted to it. And so even if it's a bad experience, we want it enough that we're willing to tolerate it, right? Very few web properties are like this. New web properties have no chance. People will get frustrated and leave before they wait for your spinner. And so he mentioned, he was talking to the team behind X, and they are well aware that if they remove the spinners and actually make it partially pre-rendered and faster, all of their business metrics go up, all of them unanimously without question. Time on the website, time to first byte, and time people spend scrolling, therefore looking at ads, all of that goes up. So there is a case to be made for, yes, the performance matters, but how React, Solid, Astro, whatever gives it to you, doesn't. Because at the end of the day, a framework is just a tool, and you can be effective with a tool. Like if you go to a gym and you want to lift weights, but it's a crappy machine, you can still lift it and get some benefits, as opposed to, you know, going to like the best gym in the whole world. Anyway, that's, Attila, you had a response.
He always has. Or shall we go to questions?
Yeah.
So let's open for questions then. You can ask about fine-grained reactivity in React if you want, but I just want to make sure that you all, at least one or two of you can ask questions. So, who wants to ask a question, raise your hand. Okay, you in the front. Can you bring the microphone here? And for this person, we're going to give away a book of Tejas. So I'm also going to ask the volunteers to take in this book. Make it a good question, exactly. That's what Tejas said.
Hey.
Hey?
What do you think about progressive web applications? Do they have a future?
Progressive web applications, will they have a future? So what's your take on that?
Okay. So you asked about PWA to the Tauri framework guy. I think PWAs are very nice. So just to make sure we are on the same page, so PWAs is when you augment your web app with a service worker, which is essentially a JavaScript that gets installed in your browser and brings some native-like functionalities. So with that, you can have like push notifications, you can have local caching, you can have access to some like native APIs like the camera, stuff like this. So I think that the PWAs are a very nice initiative. I think they exist in probably in a transition state where you need to augment your web app in a certain way and give them like a native-like experience, sort of. So I'd like to see them grow and become more popular. I do like the web technologies a lot. I hope that they can still exist like that. But there's still going to be a case for like installed apps, at least while we have app stores and play stores and whatever stores, because no chance in hell they're going to let PWAs take all the cake.
Anyone wants to add something here? Okay, Matheus?
Full disclosure, I'm also biased because I've been a native iOS developer before, so. But I do see, so yeah, first I do see future in a sense, but I feel like we have some technical barriers on the way that are still being addressed. And I don't mean specifically just Apple and just Safari and this whole narrative that's been going on for years, and that's way better now, by the way. But if you check a lot of APIs around sensors or around a lot of APIs that are designed for mobile usage to be used in normal devices, they're still not adopted. They're still not implemented in Firefox and Safari because of their security policies or their approaches to address this kind of thing. And I don't see this changing that soon for this thing. So tech-wise, this would be my concern. And on the other end, from a product perspective, I think that there are a lot of places where you as a user still need or still want an app that you're going to, like a regular native normal app. And my case for PWAs would be something like Uber, what the Uber Lite thing that you used to have. So if you didn't have the Uber app, but you still needed to get a ride, you would get a very, very simpler experience via a PWA and etc. So that would be, from a product perspective, the future I see for PWAs, like lighter versions of certain apps and etc.
Anyone want to add anything else? Okay. So anyone wants to ask another question? Okay, so there's two hands. The person in the back asked.
People are going to ask questions because they know that there are books now.
What did he say? I didn't hear what he said.
People are going to come up with questions now because there are books.
Yes. They just told me to throw the book at you. Now, I'm not going to throw the book at you. I'm going to ask the volunteer to come here and give you the book while you ask your question.
Thank you. So I just wanted to ask a quick question. So in the past, a couple of years ago, we had a focus on server-side rendering with PHP, and then we saw an evolution going for client-side compilation with React and all the other frameworks that came to be. And now we're seeing another shift to server-side rendering again. And I was just wondering, on your opinion, if we're going to actually stabilize on server-side rendering, or are we going to go back and forth?
Server-side rendering was the way, like, when I was a child, and it is the way of the future, and it was always the way, okay? And this is maybe the hottest take you'll hear from me, but I think single-page applications were a mistake. I think React, the Atom logo, the intention of I wrote the book on this, so I feel somewhat entitled to say this. I think it was supposed to be, you create a route for an interactive island on your website, and you attach React to that. and you represent an interactive component as JSX. But the rest of your site is server rendered or static. Sort of how Astro does it. I do believe Astro is the way the web should have been since 2012, 2013. And so before React showed up, and people were like, wait, the entire page can just be JavaScript. Again, a mistake for many reasons. Like nowadays, if you go to twitter.com without JavaScript, you see nothing. And so that was just, let's think of that as like the COVID-19 pandemic. It was like one of those, like, we don't know what happened in those years. Lots of things went wrong, okay? But before that, we had PHP on the server. We had .NET, we had Rails. All these years later, guess what? It's just JavaScript on the server doing the same thing. And so that is the paradigm. There is no other paradigm. The other paradigm is an experiment that works in some cases. Now, it's not always bad. This is the thing. People are going to hear me and go like absolutists, and people go on Twitter and be like, oh my God, he said that. Look, this is not like absolutes, okay? Like internal tools, desktop apps that you want for local stuff with like Tauri, for example. Even that you can technically do with a server. In any case, there's places for it. Back office tools where you don't care about the whole world as an end user because you're behind an intranet. Like there's places for it and you can move faster. But I think if we're doing something mass market, mass media, that has always been the way. And therefore it is stable, to answer your question. That's, again, my opinion may be wrong.
In short, if I may?
Yeah.
Oh, go ahead.
So I feel like, I don't want to say that they're the future, but one thing that's been happening now and will continue to happen in the future is that we'll have more and more different attempts to play with the boundaries between client and server. So this has happened in the past with different efforts. More recently, in the backend communities, we have Hotwire, Livewire, we have like Elixir, the Elixir community, Ruby community. All of these communities are playing a lot with this. I think things like Quick or React Server Components and etc. are like a similar attempt to play with this boundary and proper allocate code, but coming from the front-end community. And I think we'll have more attempts, that's one thing. But at the same time, there are also things that were trending in the past, and I don't think there will still be use cases for them, like local first apps and this kind of thing. There will be tech conferences where you find talks about it. There will be people with very good cases or decentralized app, this kind of thing, that they will still exist. And they, by definition, will somehow collide with a future that's only about server. So I'm kind of +1 to his last conclusion, that is, there will still be cases for a lot of this kind of thing. What's going to happen, in my opinion, is more attempts to properly collocate and respect the boundaries, but have a proper DX as a final solution.
DX mentioned.
So I think that I think that there is one thing to note is that the server-side rendering that we have today is not the same server-side rendering that we had before. And yes, having something that is entirely dependent on the client is not a good practice today, but it was a road we needed to go through in order to get where we are now, because I want anybody here who loves the GitHub experience where you merge a pull request and then you have a list of 5 items, but the counts show 6. Who likes that? That's state tearing that happens because you're rendering components exclusively on the server. So you need to have some single page application functionality, which means for this kind of stuff. So this is possible to happen if you start to opening the divide. What we have today with the server side, the server components, and this kind of logic that is able to start on the back end and ends in the front end means that we're closing the gap for that state tearing to exist. So it's not that we're getting closer to what it was before. There are people that are trying that with, he mentioned Hotwire before, all those Rails app before. The performance is, it gets you an initial first load, but like when you have an app that hydrates and that can do can synchronize with the backend, once you pay that initial tax to render what you need, it's way snappier. So they do talk a lot about that. If you have something no build, exclusively server side, and then you break your components and render the components on the server, it's going to be faster. But they're only talking about the first load. So there is all that. So it was a necessary role. Like if you see like a lot of the stuff where we are in a bad place, human beings just tend to go to the other way around. So it happened that we had something that was extremely dependent on the backend. Like us as front-end developers could not go anywhere without talking to the backend team. And we were like, if you had a company that the backend team and the front-end team didn't connect very well, it was a pain in the behind to ship something. But then what happened is, okay, so let's bring all the logic to the front end because then we can ship stuff by ourselves. And then once we had all the logic in the front end, we started seeing a bunch of blank pages. Google went ahead. Now Google crawler can read JavaScript. And then we're like, okay, but now we have a better ideas. So I do think that what Astro did was actually addressing that particular kind of scenario. But Astro itself is not the whole solution. Because if you have highly interactive apps with the whole state tearing and stuff, you need to have something on your client side that can actually synchronize the state. Like what Alien did here, showing like the like buttons and stuff. If you have another piece of your UI that's counting on the likes as well, you need to have a way to connect them to. And Astro doesn't give you out of the box an ergonomic way to do that. So that's why you have other frameworks like Solid Start, like Nuxt or whatever, that can actually do this integrated logic. So it doesn't answer the whole story. It is a big part of the answer because most of our apps are actually very static landing pages and then we download 50 kilobytes of JavaScript. So all the frameworks are trying to solve that in many, many ways. Astro just solved that in a very medieval kind of way. Like, okay,
thank you.
No more. But it does addresses a lot of the issues.
Okay, so we are out of time. Alien, do you want to wrap up this discussion with final thoughts on this
I'll give a very short answer that I think is the same thing I've been saying for 3 years, is that the answer lies somewhere in the middle, right? Do you know like how a small kid draws like a Christmas tree? They always go back and forth, and they go up. And basically, they end up in the middle, and then they create a triangle. I think that's basically what we're doing. We had server rendering, and then we got full client rendering, and now we're going back and forth and back and forth. And somewhere we want to end up in the middle and the top, and I think that's the final answer. But to get there, we'll need a couple of more years. But we'll get there eventually.
Oh, that was a really beautiful way to wrap this up.
I'm a philosopher, man.
So now we are getting ready to finish this panel. Before I say the next words I want to say, I just want you to thank our speakers. Can I get applause for them? So now is where the fun begins, because we have 18 books to give away from Tejas, and Tejas then will sign them. The two people already got the book, they can then also get the book signed. I'm going to ask our volunteers to bring that table that's on the side here. And does everyone see that square on the floor here in the front? Yes? Okay, so the first 18 on the line get the book.
What's going on?
The first 18 people on the line will get a book.
That will work.
So now they just bring your chair downstairs, please. And I'm gonna carry the book.
Shouldn't they fight more?
No fighting, yeah. Yeah, downstairs, bring the chair.
I'll follow you. I'll bring you.
Okay, double key. So, what line? Oh, so people are using the foot to cross the line, to set up a line. So, here's a pen, because we scheduled the book signing and we forgot the pen. Here's a pen. And who was first? It was you, okay. Here's the first person. So let's get these books going.
Give me a minute. I still have mine. But I'll come back.
Okay, now I'm trying to check this footwork here. So there's one here, one here. Okay, this is going to be interesting. So now I can play a game. What if I make like this is even crazier? Who has some credits from the sponsors? Does anyone still have credits? The gamification tokens? So who wants to swap one gamification token for a book? Okay, that person in the back was the first one. You can skip the line. See, that's Russian playing roulette. Thank you for the token. You can stay on the line if you want the signing. This is just having fun, man. I don't know how many people are here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that's 17 books, so there's still hopes for all of you. Let's see how this goes. And this is a really, really good book. I can tell you that I was part of the review panel. Me and Mateus, who's also here somewhere, he also helped review this book. And I can definitely tell you that this is the best book on React written to date. They just definitely did a fantastic job on it. And this is just me stalling some time. I can shut up for a bit. Sorry? I'm carrying this small microphone here, very close. Where is our... Oh, because now we're getting our testing stuff. Here we're getting ready. Our next speaker is doing the tech checkup, which is amazing. That microphone... Oh, okay. I'm just going to swap out microphones. I'll be back. The next person in line is... That's Ricardo, right? It is Ricardo. So he's going next. Sir, don't cheat. I can see you from here. I see someone moving their foot front higher. It's not working. But he's going to be using server components after. There were two talks, then we saw, like, we need to have this talk. Well, Ayub was one of these talks. When we saw this proposal of having a case study about web performance, we're like, okay, this is exciting, because I love case studies. I don't know about you. There's something about learning what people experienced, what people struggled with, and what they've learned that made it exciting. So, without further ado, I'm going to start introducing Ayub. Ayub is Academy CTO at Servio. I got that right? Yes. Woohoo! I got it right. And he's going to be telling us all about a case study about web performance. So I'm going to ask you to make as much noise as you can for Ayub. Woo!
Like they say, so my name is Ayub Alouane. I'm CTO Academy at Servio, based in Paris, but originally I'm from Morocco. And today I will talk about web performance and more specific about the African case. So the first question that people may ask is why the African case? Why this case is important? So to explain what, maybe we should start with small context to get what's going on there, and after we will understand why. So I will start with simple statistics here that show the penetration rate of internet in Africa. Okay, and like we can see, the world average there is about 70%. But if we go to Southern Africa, it's a country that is developed, so they have more. Northern Africa, like countries like Morocco, Tunisia, and all of these countries, they have a better internet penetration. But if you go, for example, to the middle of Africa or the Eastern Africa, it's so low. And why? Because they don't have really a good infrastructure there, so there is no ADSL or fiber optic. And what is the problem that came with that? If we do another statistics with the devices used in Africa, we will find that the most devices used are mobile phone, okay? So generally, people in the middle of Africa and in Eastern Africa doesn't have access to laptops, for example, because they are not affordable for them. So they use mobile devices. If he should go to work, he want to do something in internet, he will use his mobile device, okay? And I think that the 23% of laptops there and tablets are more likely in Southern Africa and in the Northern Africa. If you go to the middle or on the Eastern of Africa, I think most people, if they use internet, if they have a device, they will have a mobile phone. So the third question that we can ask here is if they are using mobile phones. Here, maybe we can see another thing here. For example, we can see a statistics for the price of 15 gigabytes of internet. Okay, so we can imagine here. So if you're watching a video in YouTube with the quality of 480p, okay, 1 hour of this video, it will take you 500 megabytes of internet, okay? So if you watch one video per day for a month, you will consume 15 gigabytes of internet. I did well the calculation, I think, yes? So if someone in middle of Africa or in the eastern of Africa, he bought 15 gigabytes of internet per month, he has a right to watch only 1 hour of a video in YouTube per day, okay? He can't do more. And we can see here statistics for the minimum wage in some places. So for example, if you go to Benin, and when I say the minimum wage, it's the minimum wage per month, of course, okay? So the minimum, and generally the minimum wage is the wage, okay? That's what's going on. And if we see, for example, a country like Benin, the minimum wage is, I think, $70 for a month. And if he wants to buy 15 gigabytes of internet per month, he should pay the 50% of his salary, okay? I don't think that he will buy 15 gigabytes of internet. So maybe he will not buy it, or he will buy only one gigabyte or something like that. Okay. So this is the problem of accessibility of internet there, because they rely on mobile devices. There is no infrastructure of fiber infrastructure of fiber optic or ADSL. So they should use mobile devices with mobile internet, so they will consume more data. There is no unlimited data there, okay? And we have another country, for example, like Chad, it's the same thing. Cape Verde, it's the same thing. Burkina Faso, I think the minimum wage is the same price as 15 gigabytes of internet. And if we go to another country, like Zimbabwe, the price for 15 gigabytes of internet per month, it's 3 times the minimum wage, okay? If we see, for example, Malawi, it's, I think, 4 times the minimum wage, okay? If we see Namibia, it's, I think, 3 times the minimum wage. So if you want 15 gigabytes of internet per month, maybe he should not consume anything and get 3 months' salary to buy it, okay? So here, what I'm trying to talk about here is if we are working on our web, if we are doing applications, and maybe if they access internet, I'm sure they will not access YouTube, they will not use YouTube, they will not use videos, they will use only what they want for their classes or something like that. So if we are working on some websites and we leverage on the website, for example, to the browser 30 megabytes of internet in every load, maybe we'll consume 2 salaries of a guy in the middle of Africa or in the eastern of Africa. And that's why I'm talking about web performance and the African case. Because when I started talking about the web performance, how we should not leverage a lot of JavaScript to the browser and all of that, maybe in the European context or in US, some people find it not so relevant, okay? No, we have internet, it's cheap, we have access to fiber optic, so we don't care. But for other peoples in other countries, in another continent, maybe we should care about that, okay? So we are here talking about mobile devices. I have another statistic here for the most mobile devices used in Africa. If you can see here, you can see, so the most, we have Apple. I don't think that is really used there. It's between 2 or 6%. And the most used devices are affordable Samsung and affordable smartphones like Tecno, Itel, Xiaomi, Huawei. So, and when I'm saying affordable phones, I mean that it's not a phone with 12 gigabytes of RAM, okay? So it's phone with the 2 gigabytes of RAM or 3 maximum. So that's what they can use. Why I'm talking about that? I'm talking about that because we should not have a browser that consumes all 2 giga or 4 gigabytes of RAM, because if we are thinking about people there, they can do it, okay? Because they are using internet that is so expensive, so they should consume less internet, and they are using phones that don't have good resources like RAM or CPUs, okay? So we should care about that also when we are working on our websites. I have another statistic or not? No, okay. That was it about the African context. I think that now you have another view of what's going there. And here I'm talking about the middle of Africa and the eastern there, and how I get interested in this case. Because one day I was doing an interview, a work interview in my company with the guy who is living in, I think, in Burkina Faso. And we finished the interview, it was cool. So I told him, I need to do another one tomorrow, okay? And he told me, no, I will not do it. I should planify that in next week. So I said, why, you're working, you have something? He told me, no, because I should rent a local disk to do the interview with you. And I should rent it for an hour, for example. I told him why. He told me because I don't have internet, so I should go to the city, to the center of city, to rent this local to do the interview with you. Because If I'm in my house, I don't have access to internet. I will pay more money to get mobile internet to do the interview with you. And I started doing some research to see if he's talking because it was so strange for me to rent a local to do an interview work. Okay, but I found that he was right. Now, there is the African context, but there is also other cases that we should care about. We have, for example, here Core Web Vitals that are metrics introduced by Google. But before talking about Core Web Vitals, I have a picture here. So I wrote in ChatGPT, generate for me a Moroccan guy who is waiting for a couscous. Okay, this is a Moroccan couscous. I don't know if there is some restaurants, Moroccan restaurants here in Coimbra. I don't think so. I searched for that, but I didn't find. In Lisbon, I think, yes. So imagine if you are in a restaurant and you want to eat a couscous, for example, but when you told the waiter that, he said you should wait for it 45 minutes and you should pay $200, okay, or euros. I think that's too much, okay? So maybe you will not wait. You will go and search for another restaurant. Maybe you will wait, but you will never come back. And maybe you will write some bad reviews in Google, okay? So what I'm trying to explain here is there is a user experience. We should care also about the user experience. If we are working on a website that we should wait a lot of time to get it, that's not a good user experience, so maybe the user will go and search for another website. And not only that, we have Google that introduced some metrics like largest contentful page, and they use these metrics to rank your websites in Google search, okay? So they rank your website based on its performance, okay? So here we have, for example, large contentful page. It means that it score the most largest content in your website. If you have, for example, an image that took more than 4 seconds, it's poor. They will not rank you well, okay? That's not good. If you have, for example, cumulative layout shift, what is cumulative layout shift? Cumulative layout shift, like we have here, for example, I found this example, so I used it. For Financial Times, when you click on ft.com, you get this page, and when you want, after 2 seconds, click on sign in, you will get this ad, okay? And you will click on the ad. That's not a good user experience, so Google is detecting this cumulative layout shift in your page, and Google scores your page based on that. So if you have a lot of blocks in your website that move a lot, they will score it bad, and you will not get your website ranked well, okay? And we have something else called FID, first input delay. So first input delay is the time taken by, for example, if we have a button that is displayed, but it's not working. Sometimes you click on a button, but it's not working, but after 2 seconds, it works. Why? Because when you clicked on this button, you didn't have JavaScript for it to work, okay? So after 2 seconds, it downloaded JavaScript, it executed it in the browser, and now it's working. So Google is also tracking that. So if you have a button, for example, that take more than 300 milliseconds to work, it's there, but it's not working, it will not score well your website. And that's not good to be well ranked in Google search. We have another things here, for example, like websites, like for example Cook, that improved their websites only by 850 milliseconds faster, and they got 7% more conversion. So we have the African case that they are looking only to get access to internet, but when we are in other countries, they need to sell. We are in capitalist systems, so they need to sell more, and if you want to sell more, you should have a performant website to do that. If you have an e-commerce website that doesn't perform well, people will leave it and go to another one to take their things, okay? So here I will talk about the web evolution. So I will start with the SPA that we get after 2010 with the AngularJS. So how it's working normally? So for example, when we have a website that we've done with our SPA frameworks, it's working very simple. You send the HTML that contains nothing. You wait for your page to be loaded. So after that, you download the JavaScript needed. You execute the JavaScript that you need for your website. And after that, you render the JavaScript, and now you have your page working good. But there is a time here between the page is displayed and it's a blank page, and the page is interactive, okay? So what we try to do with hydration is that first we send an HTML that contains a lot of information that you need to display your page, but your page is not working, okay? Because there is no JavaScript. It appears faster, but it's not interactive, and you should wait for your JavaScript to be downloaded. You should execute the same JavaScript, and now you can do the process of reconciliation or hydration to get your page working and interactive. And that's why we're talking about FID, the metric of Core Web Vitals. It will calculate the time between your page is there and it's working, it's interactive. And if you take a lot of time between these two steps, it will not score you good. So here, why I'm talking about problems that we face maybe in our web and globally in web performance. So maybe we should present some solutions that we have now in our field. So I will go to what? Okay, so this is a good graph that I have here for correlation between performance and JavaScript and interactivity. Like you know, in these days, we need more interactivity in our websites, okay? So if we need more interactivity in our websites, we need more JavaScript for our pages. If we want more JavaScript for our pages, we should download more JavaScript, we should execute more JavaScript. That's not good for performance, and that's not good for the African case, what I'm talking about. If you have someone who is downloading more than 30 megabytes, that's not good, and if he's executing 30 megabytes of JavaScript in his browser, it's not good for the resources of his phone, okay? And now I will talk about resumability. So resumability, it's a paradigm presented by Quick, a new framework called Quick, but it was already there with Wiz. Wiz, it's an internal framework in Google. And also for Marco framework, it's an eBay framework. So here, how it's working resumability. So it's the same thing. We send your HTML, your page is displayed, but now it's interactive. So the question here maybe that we can ask is how it's interactive without JavaScript. Because in the HTML that you send first, you will get a small code of JavaScript, 1 kilobyte, that contains a global listener that listen to your interaction of interactions that you do with your websites, and it will go and execute the JavaScript needed for this interaction. Okay? So that's how it's working. How can I show you that? Maybe I will do a demo to show you how it's working, okay? And if we use this paradigm of only download and execute what we know, what we need for the JavaScript for our website, what we need to interact with, I will not download all the JavaScript for my website, like if I use SPA, for example. If I do that, I can scale my app, okay? You can have all what you want in your page, but will not execute it, because the user didn't interact with this yet. So to show you that, I will show you a demo. I have 7 minutes for that. I wish it would be, okay, so I see if it's going. Okay, so what I did before, I created here a route for my JNation, and I created my first component. I only did the small test, and here it's working fine. Okay, so here what I did is I did minus Vite because I don't need Vite in production. I have it in prod, but here I'm showing the JavaScripts that I will download in the first when I will show my page. If I reload my page, I will download nothing. I don't have JavaScript files. If you're using SPA, you will have bundle.js that you should download in the first time so you can interact with your page. Here I'm using Quick, so I have nothing. If I use all, you will get your CSS, your HTML, and that's it. So if I use JS, there is nothing. And what I will do is I will create here a simple button, okay? I will call it JNation. And here, I will call it. So I will start with a simple button, okay? I will do a simple on click. And here, I will use simple console log. So what you should imagine here is that behind this console log is your JavaScript code, because we are doing a simple demo, so we will use only a console. But when you're working with your website, you have a lot of JavaScript to display in your website, okay? So here, I will save. I have my button. And when I refresh the page, I have nothing, okay? So after clicking on this JNation here, I will get the JavaScript needed for this button only, okay? So why I'm talking about, and if I create another button, for example, here, I will add another one. I will call it Lisbon, okay? JNation Coimbra, okay? If I click on this JNation button, I will get the JavaScript needed for this one. I will get it executed in the browser. And if I click on the second one, I will get it now, and it will be executed there, okay? So what's the good thing about that? Is that Quick is using, in the background, a service worker that take the job of downloading the JavaScript needed, the chunks of JavaScript needed for your buttons or for the interaction that you will do with your website, and only what is displayed. And they will store that in the cache, okay? But they will execute nothing, okay? And that's good for the performance of your hardware that you are using. So you will not have a DOM that is bombarded with a lot of JavaScript that is executed already, but you don't use it. Here, and what it will do, it will delay the execution of your JavaScript. It will take time. If you interact with something, it will execute it. If you don't interact with that, it will not use it, okay? And that's the good thing about using Quick. Here I will do another example. So I will take an example of a code that I need when I will start my page. I will take a simple clock. So here I will do import. And here I will call my clock, okay? If I go to my website, what I can see now is that I have the JavaScript needed for this clock because I should display it the moment I show the website. So I need to download this JavaScript, okay? Because I'm using here, use visible task. When it's visible, you should download it from the start. You can't delay the download of that, okay? So like we can see here, it's working, but imagine that we have this code that is in the footer, for example. You have JavaScript that should be displayed in your first page, but you will not show it when the user will click on your page. So it will be in the footer, okay? So here, for example, we have no JavaScript because it's not shown, it's not executed, because the user will not use it now, okay? If we will scroll and go down to our page, it will download it will execute the JavaScript, but it downloaded already in your service worker and stored it in the cache, and now it will execute this JavaScript here. So what I will do is I have nothing, I scroll, and I will get this JavaScript that I need. Okay, so why I'm talking about that? I don't have a lot of time to show you a lot of demo, but if I have to finish my talk, I will finish it with the slides that I showed you already. And it's also why I showed this demo and to talk about web performance is to really see that there is other cases in the world that maybe for us it will be relevant to use some new paradigms, but for other peoples in other countries, they have less access than us, they have less hardwares that are more performant than us, they are relying on affordable phones, and they are relying on an expensive internet for them because they don't have access to internet, because they don't have good minimum wage there. So they can, for example, like I showed you here, if they want to watch a video of 1 hour in YouTube per day, they will take for them 3 months of salary if they do that, okay? Because the minimum wage there, for example, in Malawi, it's the price for 15 gigabytes, it's, I think, 4 times of the minimum wage. And that's why we should care about web performance. We should care about the JavaScript that we are leveraging in our websites. And that was my talk, and thank you.
Wow, what an amazing talk. And a fantastic closing. I think it was really, really eye-opening. Thank you so much for joining us, Ayub. Something else about Ayub that I don't know if he told you, he's organizing a conference in Morocco, isn't he, right?
Yes.
JS Morocco.
Yes, it's here.
It's the t-shirt he's using. So we still don't have a date, right? Or do we?
We still don't have a date, but if you want to visit Morocco and to come to the conference, here is a code that you can scan, and we will communicate the date after, and also the city where we will go to the conference.
Amazing. I'm excited to see how it goes. We have some people scanning, so I'm going to give extra 10 seconds. Okay, thank you so much, Ayub.
Thank you so much.
Another pause. Okay. So we are 2 talks to go. So before I introduce our next speaker, I want to ask, who here is using NX? Okay, we have 3-4 hands up. So our next speaker is actually helping build NX, right? He's a senior software engineer at NX, and he's telling us that this talk doesn't qualify you to fly spaceships. I think that's something it said there. I'm excited to see how this goes. Something else about Max. I love in his bio, he says he's a huge sci-fi nerd. We still need to have a discussion. I really want to geek out with you, because in case you didn't notice, I'm a huge nerd as well. So, let me stop from speaking. I'm going to give the floor now to Max. An applause to him.
I'd like to start off by telling you a story about a guy named Dan. So this is Dan. He's a mechanic, and his job is fixing spaceships. So here you can see him at the station bar, you know, having a beer that is technically derived from fungus, but he's used to it, he's enjoying it, he's having a good time. And Dan is really a metaphor for all of us developers, because like any developer, Dan is going to go through the cycle of being cautiously optimistic, falling into a pit of utter despair and confusion, but he will come out on the other side feeling like he's understood everything. So my name is Max, and I have gone through that cycle of disillusionment and understanding many times in my life, and I'm hoping that with this talk, maybe I can make it a little bit easier for all of you. So as you probably guessed, this talk is about monorepos, and I work at a company called NX. We do monorepo tooling, and I also work inside a monorepo all day, every day, so that's my perspective on things. Just to give you an overview, I'm going to start off by talking a little bit about polyrepos, which I would say are the current standard way of developing software, what they do well and where they fall short. I'm going to talk about monorepos, what issues they solve, but also what issues they potentially introduce and why we need good tooling in order to fix that. So as I said, I want to use Dan and his job fixing spaceships as an analogy of sort to get my point across. So remember, in the next few slides, one spaceship equals one repository. All right, so on the first gig that Dan hires onto is actually a fleet of spaceships. In the front, they have some, fast ships. They're fighting space pirates, they're exploring, they're doing all the cool main character stuff. In the middle, there's some utility ships, and they're just handling repairs or transporting crew. And way in the back, there are some ships that take care of supplies and communication with the home station. So all of these have distinct responsibilities in the fleet, and they're all connected in some way. And I think this is a very logical way of organizing a fleet of spaceships like this. And it transfers. I would say this is a very logical way of organizing code as well. So the great thing of this is team autonomy. If we have one repository, or one spaceship in this case, for each team or each project, each team can make their own decisions inside that project, do what they do best in their domain. We also have technological autonomy. So you can see in this example, some teams are using React, there's another team that's actually using Angular. They can share some code with TypeScript, and the backend is written in Kotlin. So the cool thing is, because all of this is structured, this means, sorry, 1 second. Right, because this is all structured, it means we have a clear architectural overview of this entire system. So to summarize, I would say that polyrepos are great because they offer you team autonomy, technological freedom, and a cleanly separated architecture. But let's have a look at where they fall short. So let's imagine the web app team and the landing page team, they want to share some code, right? They want to factor out some shared React hooks that they want to both use. How would they go about doing that? Well, in this case, they would have to first set up a new repository, set up linting, testing, and building. They would have to set up a CI pipeline, publish it to some shared registry, and they have to make PRs in the other places where they actually want to use the code. And then only can they test everything together. So as you can imagine, this leads to a lot of code duplication because no one wants to go through all those steps. So they're just like, you know, this once I'll just copy this code over, and of course it's not just once, it happens all the time. And now it's completely separated and decoupled. So the code that exists in one place doesn't know about any of the other places. Maybe there's a bug that's found in the code. The other teams that use it are never going to know about the bug. As you can imagine, this does not scale very well. So as the project grows, teams are always going to be on different versions, scared to upgrade and introduce some kind of breaking change or the like. But even if we look at just the front-end portion of this, let's say one of those bug fixes required a React version upgrade. You know, everyone started out in the same version and in sync, but then life happens, kind of. Some teams can upgrade, others can't because there's a blocker, and now everyone is in different React versions. And nothing is stopping them, in this case, from importing components from one another. Who knows what could happen if I import a component from React 17 into React 15? It might work perfectly fine. It might break horribly somewhere down the line. And the same goes for back-end, front-end relationships. So let's say the back-end team has some shared interface that they expose via an endpoint. If they break that without coordinating well with the front-end team, they might just break them completely in production. So as you can imagine, in the end, this results in a kind of state of constant fear, where everyone is afraid of moving, of upgrading, because they have this fragile equilibrium that they built, and they don't want to break it. So while polyrepos are great, especially for team autonomy, they also cause issues because of inefficient code sharing, because of high code duplication, and because of complex dependency management, all of which ultimately result in isolation. So Dan has been through all that, and he's not happy. Like, he just spent weeks trying to fix issues that should not have been there in the first place. He has sat hours and hours in meetings trying to coordinate with all the other ships, and he's back in the bar, he's drinking, but he's not happy this time. And I can sympathize. But then he finds a new approach, the Monorepo. So instead of a fleet of ships, they actually just have one large ship. They still have autonomous teams in there working on their own, but they all share one large ship. And it seems like a daunting approach at first, but it has a lot of benefits, which we're going to learn about. So before I dive too deep, I want to kind of get aligned on what a monorepo really is. So I like this definition, which reads, a monorepo is a single repository containing multiple distinct projects with well-defined relationships. It's quite a mouthful, so let's go over what it means. The first part seems pretty obvious, right? Multiple distinct projects. If I have just one application in a repo, that's not a monorepo. That is probably a monolith of some kind with no discernible internal structure. So I definitely need multiple projects. But even if I just add 3 apps in a folder, that's not a monorepo, that is code co-location. And that brings us to the second point, well-defined relationships. So as soon as I start breaking out certain pieces of that code, and establishing clear relationships between all those projects in my repository, now we're talking about a monorepo. And it has a lot of benefits. The first of them is atomic changes. So do you remember all that was required in order to make a fix to a shared library in that polyrepo setup? You have to make a PR to the library, test it, publish it, and make other PRs wherever you want to use it, test everything together, and maybe you have to go through it again and again. Well, in a monorepo, this becomes really simple. Because those apps import from the shared folder directly, I can just make a change to the folder, and it's used instantly in all the other places. And as you can imagine, this makes code sharing a lot easier as well. So instead of setting up a new repo and everything, I can just create a new folder, import from it, and that's that. And in turn, code duplication becomes way less, because people don't have this huge overhead anymore in order to share some code and reuse it. They'll gladly do it if someone else has done the job for them already. Because everything is in one repo now, we can very easily have workspace level dependencies instead of individual dependencies. We call this a single version policy. So let's say I have one React version, I have one TypeScript version, and the like. Now all my projects share that version, and I don't have to worry anymore about any of those hard to trace bugs where I'm importing a React 16.1.4 component in a 16.1.3 application. And by extension, creating new projects becomes way easier as well. So I can just set up a new repo. I don't have to worry anymore about my new CI tooling or about testing linting or about any of those workspace dependencies, because they're already all there in the workspace. And that brings me to my next point, which is consistent tooling. So as you can imagine, in a polyrepo world, everyone finds their own solution to problems, right? And that's great. We want the team autonomy. But it could be simpler. There are things that can be shared. Let's say certain teams agree on one way of building things, on one way of testing things. In a monorepo, they can do that. And then they can share a lot of configuration. And that means that when any developer goes into any of those projects, they'll instantly know their way around, and everything is built consistently. So in summary, I would say that monorepos really give you three things: velocity, safety, and mobility. And all these things I talked about, they contribute here in different ways. But I'm not going to go over all of them. But just an example, atomic changes, which is really important. They make sure that everyone can easily and quickly commit code that across the entire stack, the entire repository, so that's really fast instead of juggling versions around all the time. You can make sure that in any one state, the entire project works together. No more insecurity, making sure versions are aligned and stuff. Everything works together on any given commit. That's safety. And also, because any developer can really easily and quickly contribute to certain parts of the code base, they're more mobile to move around and contribute everywhere. So that's developer mobility. Monorepos require a certain level of collaboration though, and that's why I want to add this disclaimer. If your teams hate each other, they won't like working together in a monorepo. It seems obvious, but something that is often misunderstood about monorepos is people are worried about being too tightly coupled to other teams. And it makes sense, especially if they don't like those other teams. But that's actually a misconception very often, because in a monorepo, you still have complete autonomy over who contributes to your code, over what kind of technologies you use, and when you release or publish or deploy a new version. But still, there is a certain validity to the argument, and that's why I would say there is a certain level of collaboration that is required to work together in a monorepo. For example, you need to agree on the monorepo tool you use. That's like the very baseline. You probably also have to agree on the CI tooling that you use. And if your teams hate each other, they won't like working together. Then again, you probably have an organizational problem, not a technological problem. I really can't help you with that if your teams hate each other. But it allows me to make another really important point, which is that monorepos are not an all or nothing kind of thing. So we at NX, we build monorepo tooling, and we still have multiple repos. We've one for the NX open source code and plugins. We've one for NX Cloud and infrastructure and closed source code and the like. And we've one for the editor extension, which is separately versioned, and it's mostly historical reasons, honestly, that it's in a separate repo. But that's fine. Most of you probably aren't Google. You need to have one gigantic monorepos where tens of thousands of developers commit. You can just incrementally adopt it, group things together where it makes sense. You can have multiple repos. It's fine. All right. So I think we can all agree that monorepos are great. I hope you're all as excited about them as I am, or like half as excited about maybe. And I'm going to be using NX in this next section to talk about where we could face issues, maybe, and how good tooling can help with that. I want to give a shout out, though, to this site, monorepo.tools, which is a great comparison over different monorepo tools, because there's not just NX out there, of course, and all the authors of those tools actually contributed, and it's as unbiased and up-to-date in a comparison as it could be. So definitely check it out. I'm going to go out on a little bit of a limb here and make a very bold claim, which is running tests takes time. I know, maybe it's not the hot take I thought it was. But the thing is, if we then have a monorepo and we have a lot of projects with a lot of tests each, doesn't just testing my repo become bigger and bigger and take longer and longer as it gets, as the repo grows? And the thing is, yes, but with good monorepo tooling, it's not going to be a problem. So how can we make it faster? By analyzing source file imports and through configuration, NX can build this project graph of your workspace. You can see here, there's a card application, there's a product application, they probably use some micro front-end module federation thing, which you're going to hear about after my talk. And they have some shared libraries, and then they have some libraries that they only use themselves. And with this, it's actually really easy to detect what is affected by a certain change. So let's say I make a change to the product detail page. Because of this project graph, NX can tell that the product application itself is affected. And in turn, we need to run all the products end-to-end tests as well to make sure everything works. But there's no way I could have broken the card app, because no path through this graph goes from the card app to the product details page. So you can see we can already save a lot of time by just running tests and build for 3 projects instead of everything. This also simplifies CI time by a lot. It simplifies your CI setup by a lot. So we can just say, hey NX, please run test, lint, build, and end-to-end tests for everything that is affected by a certain change. And that is it. That is your CI setup now. That means that we've successfully uncoupled the time it takes to run CI from the size of your project, or the size of your workspace. Now, it's instead relative to the size of the change you're making. So if you have a very small change, it's only going to take a little bit of time. If you have a very big change, it's going to take a little bit more time. All right, how can we make it even faster? Let's say I want to run a build. There's a lot of things actually that go into deciding what's built here. We have some source files, we have some configuration, etc. Those all get together, some computation is done, and we have an output. In this case, a JavaScript bundle and an HTML file. With NX, we add a computation cache. So how this works is we take all these inputs, we can calculate a hash from them, and then we save that hash together with the encrypted inputs in the cache. And the next time I want to run my build, I can just calculate the hash again, and if it's already in the cache, I can just restore it from cache, and I don't need to do any computation. And that means that my build can go from minutes to milliseconds. And the really cool thing is that this can be shared across all of your developers in an organization. So in a big monorepo, someone is always doing something, whether that be my colleagues halfway across the world, or a CI runner doing nightly builds or whatever. So if I log on in the morning and I want to run my build, chances are pretty high that someone has already done that exact same computation for me. So that means that in a monorepo with a distributed cache, we can make sure that no computation is ever run twice, ever. All right, so that's pretty cool. We can save a lot of time. And it showcases why it's important to structure things out into libraries. They're not just your fundamental units of architecture, they're also They also allow NX to make way more granular decisions when it comes to calculating affected or doing caching. So this is great, but what if I change something further down in the graph? That means that potentially a lot bigger portion of the entire app, or even everything, is going to be affected. How do we deal with that? Well, NX has something called the task graph, and it's built out of the project graph and configuration. So here's an example from our VS Code extension, and you can see that in order to build the VS Code extension, we first need to build the language server and the Generate UI, and then we can combine everything. And because NX has this task graph and knows how everything is connected, it can do some really smart assumptions here. We know what can be run in parallel. We know the order in which things need to be run to ensure a correct build. And ultimately, we can build the VS Code extension and have a correct, fast build. So as you can see, this is already a lot faster if we run it this way than just running everything sequentially, right? Because we can parallelize. But let's be honest, there is only a limited amount of parallelization we can do. And we have to handle the worst case here, right? Where everything in the entire repo is affected by a change. So there needs to be some other way to deal with this. We need to distribute all this calculation across multiple machines somehow. Let's get back to our example of running affected, build, lint, test end-to-end. In a bigger change, potentially that's a lot of tasks that are going to be spawned from this that have to be calculated. And a naive way of distributing this across multiple machines might be, hey, let's just run one type of task on each agent. But as you can see, this is actually pretty inefficient, right? Because while agent 3 is running, all the other ones are just idle, wasting time and resources. And there's another reason why this won't work in reality. Do you remember the task graph, right? There are dependencies between all those tasks. So in this case, for example, end-to-end depends on the build to be run first. And that means that we need to make sure that end-to-end is run on the same machine as the build. Otherwise, they won't have the artifacts. So you can see how suddenly this is becoming a really complicated problem where we need to make sure that everything is run in the correct order. Everything is run on the correct machine where it needs to be run on. Everything is as efficient as it can be without any idle time, and we don't want to duplicate any tasks. And that's really complicated, believe me. But with NX, it becomes pretty easy, actually. It's just one line of code. We can say, hey, please distribute this across 4 machines. And because we have the task graph, we can make sure that everything is run in the correct order. And because we have the distributed computation, we can completely ignore that other limitation of saying the end-to-ends need to be run on the same machine as the build. We have this really fast way of replaying a calculation, so we don't really have to care about that. Agent 1 can run the end-to-end test, replay everything from cache, and it doesn't make a difference whether the build was run on that machine or in another country. So this is really powerful. And now that we have this one single line of configuration to distribute things, we can start playing around with it. Let's say we want an even faster CI time. We can just spawn a couple of more agents and it's reduced. Or let's say there's something that isn't actually that time critical, like nightly builds. We want to save some money. We can just use 2 agents instead. CI time becomes longer, but it's just one number that we're changing in the configuration, which you would be able to see. It's under the copy link in Right to Root. All right, so this is something that's really powerful, though. And it's really important because as your workspace grows, there's no way. At a certain point, there's potentially hundreds or thousands of projects in your workspace. There's no way to run it all on one machine if something at the root changes. So you have to distribute it somehow. All right, so after learning about all this, Dan is happy. You can see him. He's focused. He's doing work. He's not actually drinking for once. And if you want to be focused and content and have this amazingly chiseled jawline like Dan, I would recommend you head over to monorepo.tools and learn more about monorepos. Or you can, of course, just trust my completely unbiased opinion and head over to nx.dev and check out our documentation as well. So I would say Dan is happy, I am happy, and I hope all of you learned something. So all this I have to say is thank you.
Thank you so much, Max. That was really, really cool. Thank you so much for joining us here. Who here is going to play with NX after this? Okay, so you got converted some people in the room. I want to see what happens then. So,
If you have questions or anything.
yeah, so if you have questions, then for Max, feel free to drop him a message or find him now here. So now we're gonna have a 20-minute break, and when we come back, we're gonna have our last keynote of the track today with Zach to close the day. So see you in 20 minutes. Cool, some applauses. I hope there's still some energy, because this next speaker has a ton of energy, and this is going to be a 40-minute talk because this is our closing keynote. So I hope the energy comes back. If it's not there, it's 5:40, so I'm going to start. As people start coming back in, they'll be able to pick up the introduction. So, who here has used this thing called model federation? Okay, we have some users in the room. Exciting. So our last speaker, oh God, my brain stopped working. Our last speaker, Zach, well, he actually invented the thing, and he has been doing a lot of support, backing up. I remember when I was working at this company called TalkDesk, we were using model federation, and Zach took a lot of time to help us up with that. So he's just an overall really, really great guy. So I won't take extra more time because you want to hear Zach speak, and you're probably tired of hearing me. So I want you to make the loudest noise that you can for Zach Jackson. Still no? We have sound?
Any sound? Okay, there we go.
We have sound.
All right. Well, thank you for coming to my talk. It seems like we do have a few users who know Federation in here. That makes it a little easier. But yeah, I'm going to speak a bit about module federation and beyond. So for those who don't understand or who haven't heard of Federation before, what it does is it allows you to import dependencies or share code from independent compilations. If you've heard of micro front-end, or we just had a great talk from NX, where they kind of showed different ways that you can share your code. The idea with Federation is you can do the same thing, but at runtime. So I would configure it like that, somewhere else in a code base, different repo, whatever your setup is, you can just import it. And all the connections, or if you share dependencies like React or something else, all of those are linked and shared at runtime. So since it's been developed, it has gained some decent traction in the larger set of companies. You can see here, definitely some recognizable logos and names. And during that growth, we realized it was time for a redesign. So the main challenges that we kind of saw were software has become more complex. And what I had initially designed it to do is not living up to the demands that the users have in modern applications. There's also new bundlers coming out, and lots of workarounds over the years that have frustrated users. So we released 2.0, and 2.0 was a major rewrite that we implemented. As you can see, the goal of it is to introduce a bundler-agnostic approach, to create runtimes and SDKs, and to decouple it from Webpack. So to go over a few of the new capabilities that we rolled in here, one of the major ones is this concept of the runtime API. What the runtime API does is effectively what you could do at compile time, but you won't need a plugin to implement federation. In this example, you can kind of see it in its pure form, how we would initialize something, share or specify different modules. And again, you don't need a bundler to do this. In this scenario, I'm sharing something like React. If we look at runtime plugins, which is another feature of the new design, these work either at compile time or at your runtime. But what they let you do is actually hook into almost like express middleware, but on import. So if I say import, button from app1/button, with a runtime plugin, I would be able to intercept every part of the request lifecycle. So the import from doesn't actually mean anything. And through the runtime plugins, you can rewire your application's dependencies on the spot. These are some of the hooks, but we do have more in our docs. To give you kind of an example of what we can do with some of these runtime plugins, we have a simple example here where I'm going to go in and rewire the node modules that the application's actually using. So just from a simple UI, there's no multiple deploys or multiple builds happening here, but you can see I can change React DOM of the main application. I can change different various parts of it through just what's in the browser at that moment. Another example is if you've ever used Federation, you've probably dealt with what do you do when a dependency isn't available. Something isn't online, and that usually can crash your application. So what we ended up doing was introducing something like a error load remote hook. So assuming something is not online, that hook would fire, and pretty much whatever you return is what the export, the application will receive. So in this scenario, only app 1 is online, and app 2 is not running, and the remote hook is returning a React component that just renders the error as a string. So you could put anything in there, dynamic import a fallback from NPM, whatever you want. Another cool example that we've kind of rolled out is something like API-controlled remotes. So imagine if you wanted to control all of this from a server, from A/B testing, or AI is getting popular. So imagine the integrations there. Again, all the imports in your code base don't mean anything. They are controlled or can be controlled by a simple runtime plugin like that. So if you wanted to change out your deployment locations, perform green blues, anything like that, again, you don't have to rebuild the consuming app. This stuff is all done at runtime, so I can just swap out what header is, or which version of header, or I can roll out different variants of the application to certain regions in the world. An example is when I click on the button, I'm going to rewire the application to import, it's only called app2 button, there's no other import. But those are two different code bases, two different builds, two different releases, and when you hit the button, you can replace what app 1 is at runtime. Similar kind of idea with dynamic mapping. I configure it here, I add a runtime plugin, and again over there I can actually wire it up to wherever I want to go. Imagine localhost development on production, or using staging servers and mixing the application together. So you don't have to run everything locally in order to work on the application. So in this scenario, you can see a really great feature that a lot of people have wanted, which is the ability to dynamically synchronize remote types. So if you use TypeScript, just by doing this in one application, again, remote 1 is a different repo. The build doesn't know anything about it. But if I go in and change my types here, you will see immediately type error. So I know that a lot of people have wanted this. I'm very excited to have been able to roll it out. We've gone a step further, though, with the implementation of our type syncing. Currently, this is kind of compile time. If you have an import from or something like that, we can pick it up, synchronize all the types on the fly, and there you go. But as of yesterday, we've rolled out the ability to do the same thing at runtime in the browser. So let's say you don't know what you're importing. It's too personalized. It's too custom. We usually call this dynamic remotes. When you run into those use cases, there's nothing to statically analyze. So what we've ended up adding to this system is if you were to open your browser console and just go, global federation API dot register remote, and put in a string to register one, immediately as you fire that, the browser will send something back to our server broker, and it will synchronize the types using the information derived in your browser in development, and your types will show up right away. So another nice thing we've ended up adding is the ability to hot reload and fast refresh the application. I know this has been a frustration for a while, and we have finally solved that. So you can go in here, and whatever you type, you hit save, and again, the host application will receive whatever updates we provide it immediately. We've also introduced a really cool feature. We use this quite a bit at ByteDance, but essentially we've introduced a capability to, I can't read my title there. We've introduced the ability to implement runtime lock files. If any of you work with Federation, if you refresh the page several times, if you share something like React, you'll always get React that you want at whatever SymVer rules you've set, but you don't know where it's coming from. If every app has React at 18, if you refresh the page a lot, you can get any of those. So that's not great for caching and things like that. It's non-deterministic. So we ended up introducing this manifest protocol, and that manifest protocol allows us to do things like this. We deploy this to an edge server, and it's able to ingest all the JSON remotes, as we call them, and we can calculate a snapshot from it. When that snapshot is delivered to the application, that is your environment, not whatever you're deploying. When you do a deploy, technically, that doesn't really exist anymore, depending on your infrastructure. Your production environment is the calculation of that snapshot. If you want to redeploy production, you just update the database table that's yielding that, and your application is now up to date. And that's kind of the runtime plugin of how we would implement it, just to give you an example of how this works. We will make a better demo of this, or a repo that kind of showcases it. We've also introduced Chrome DevTools. The idea behind the Chrome tools is really just to give you an easier way to look at what's going on, to see how the application is working, to interact with it a bit, in the browser. And we've also, through this Chrome extension, are able to introduce the ability to perform fast refresh and hot module reloading in deployed environments. So if you wanted, you could, say you work on header. You can have header running on your local host, and you can go to your production URL, enable the module proxy in the Chrome tools, and every time you hit save, production will not live reload, but it will fast refresh just the element, just for you. So we've also introduced new docs, because that was needed. It's still a work in progress, but if you are interested in using it, or if you have used it already, this is a much more reliable source to get information from. So one of the things we've seen is managing distributed applications is very tricky. Where are things? What's going to break what? How do you even deploy it? How do you get the order of operations correct? And so what we ended up doing is, this is just a very quick example comparing a traditional deploy with CI compared to a deployment with Federation and a system that we call Zephyr Cloud. At ByteDance, we have a very similar concept to Zephyr called VMOC. So here you can see, going through the usual steps, do a commit, wait for the deploy to happen, and it's still going. And if you think about this in bigger applications, this increases the latency. And often I found when you're trying to deploy an environment, you spend a lot of time waiting. And for most of the deployments, at least that I do, to staging or testing environments, you do them many times, you don't really need all that CI stuff, like tests. I need that when I'm actually going to deploy it. So that's roughly what a normal build and deploy looks like. I mean, it's still going here, so you can see this should be pretty standard to anybody who's deployed a web app. And that's still pretty quick, though. But now, what we're going to do is we're going to flip over to what this would look like in Zephyr. So that was about a 30-second end-to-end. Now we're going to use Zephyr. I turn that on, and I run a build. And the application is deployed to production. No CI. It's already there. And let's say you wanted to change something in this deployed federated app. And it's already deployed to production again. That's your deployment. There's no CI. Now, how you control this and make it safe, that's where the kind of back-end layer of Zephyr comes into play. If you do want any artificial gates, like tests, or do the types match, or anything like that, that's what you can decide. But if the code is built, the code is already ready. It's already on a server, and you can utilize it. If you want to see how things are actually working, this is kind of a view that it starts to generate as it understands the links between individual code bases. You can control the versions of them. You can see where in your code base the interdependencies show up. Very similar to NX's graph, but imagine if this was done at runtime dynamically. We also have some other views like that. If I'm on the shell, what does the shell consume? And I can dive deeper into those nodes and so on. So at ByteDance, I said we have a system similar to this called VMOC. And we've been fortunate enough to collect a lot of business data around what's the actual return on investment we've seen from one, designing VMOC, and two, rolling out module federation to the majority of the company. For context, at ByteDance, we have about 1,000 business products, 15,000 front-end engineers, about 10 to 15,000 code bases, and we need to, weekly, we deploy our applications at least 10,000 times. So that's the general scale that we're trying to work with. Some of our remotes have thousands of versions. Some of our apps are composed of hundreds of remotes. And these are the metrics that we see at our company. 60% reduction in build time, average of 6 to 10 minutes saved, and that's using Webpack, which is already not very quick. 2,500 CI hours saved per week. A really big one here is 300% increase in engineering output. Our average output across any given product was, let's say, about 20 deployments a week. We now average 76 to 80 deployments a week since we've adopted federation and a Zephyr/VMOC control layer. 500 additional deployments per year to the product. That really adds up. And a 40% reduction in overall application size with 80% reduction in initial JS load. So if you do want to check out anything about Zephyr, you can always go to just Zephyr Cloud IO and kind of get a read on it. But let's go back a little bit. 5 months ago, we introduced RSPack and federation support. Has anybody heard of RSPack? All right. Has anybody heard of Webpack? Okay. So RSPack is Webpack's API, one-to-one, rewritten in Rust by our infrastructure team. It's open source, it's free, it'll always be free. But it's significantly faster. And it's compatible with pretty much every plugin and loader that's been written in the last 10 years. You can see, generally, it's about 11 times faster than a Webpack compile. And it continues to get quicker. I think this was yesterday. We just shaved another 15% off of the build. Now, what's cool here is we currently don't have any cache built in. So every time you do a build in dev mode, there's no Webpack cache as of right now. So the yields we're getting on it currently are still what I kind of call very slow. But we are in the process of introducing remote caching and distributed caching. So that means if you changed a button, and somebody else had built the previous version of the application, and you're cold starting it, the only thing you're rebuilding is button. You're not rebuilding anything else. Every build contributes into the distributed cache, and every user can receive and send from that cache. We're also looking at distributed compilation. So the idea, again, we have very large applications. Average size is 50,000 files. So even with Rust, they're still going to take some time to compile it. And so with distributed compilations, what we're planning to do is create, it's still in planning in early phases, but it sounds like something like a client and a set of daemons. So you can wake up the client and say, use 100 servers to compile this application. And again, because of the caching layer we're introducing, we don't compile the same piece or like a monorepo, certain workspaces. We can just break up parts of the graph and say, hey, just go from, random page or from carousel down and return the the updated graph to the client, and the client will seal it and give you everything that you want. We have also begun to grow the family here. We started out with RSPack, and we've introduced several other tools along the way to kind of complete our infrastructure offering. And a lot of this was just closed source projects that we use every day, and we started to look at open sourcing them for the community. So the first one I've spoken a bit about is RSPack. And you can kind of see the general speed improvements that we've seen. One of the big challenges that we have at ByteDance is we need a really, really powerful compiler. When we started designing RSPack about a year ago, we first rewrote ES-build in Rust, then we started to play around with rollup written in Rust, but ultimately the APIs just could not support the business. And we ended up moving to Webpack's API as the only thing that was really strong enough to do everything the company would need. Now, the return on investment on RSPack is also nice to see. Across the board at ByteDance, we've seen an 80% reduction in our cloud costs. That's significant, considering the amount of deployments we do every day and the number of projects that we have. We also have seen 27 minutes average savings on our builds, and that equates to about 200 hours a day per project in CI time. And from our developers' standpoint, this also relates to about 7 hours a week per developer in engineering time saved. So another client, or another user, So another user that we came across reported to us that when they moved from their current build system over to RSPack, they got a $32 million a year savings on their engineering costs. Time is money, right? And if we look at another one, 50% savings in bandwidth. And according to that report, that 50% savings, they worked it out to being in the millions of dollars in reduction to cloud costs on delivering the JavaScript assets from the CDN. We also have some other tools we've built along the way, like RSDoctor, which is like a Webpack analyzer on steroids. It can show you your overall viewpoint, what your app is doing, the sizes, any potential warnings in there, drift, compile times. You can also dive deeper into views like the files, where the bloat comes from, the module counts on them, your HTML, duplications, anything like that that you'd want to know. We can also do tree shaking analysis, so you can actually see what is not getting shaken out of the build and where. Another very useful one, if you do have a slow build, you can see the actual timings of every plugin or loader in your build. This also works for Webpack, so if you're a Webpack user, feel free to install it as well. And another really nice one here is we can also see loader times. You can get very technical and low level, like how long does it take to resolve every file in your code base, or what types, The remote isn't great on this thing. All right. Resolvers analysis, and then you could also see a flame chart of your compilation time, what's adding onto it, what's slowing it down. We've also been working on our own web framework, supports server-side rendering, generally what you would expect from a meta framework, but it has first-class support for federation built in. Since we are the largest user of federation, we obviously want all the bells and whistles, plus distributed systems, and still the same kind of efficiency you would expect. We have something called RSPress, which pretty much every doc site that you see from us, it's all RSPress based. Fast, simple, MDX supported, translations, other things you'd kind of expect from it, just on our tool chain. So looking at a bit of a roadmap here, we do have some cool things in the works. A big one is RSlib. So we've been working with the Webpack Foundation and a few other contributors on designing the compiler to be able to output good tree-shakeable code for NPM package development. So RSlib is harnessing these new APIs that we've added into RSPack, and it will give you, the closest thing I can describe to it is a meta framework for package authoring rather than last mile authoring, which is something I've always felt very frustrating to deal with. Dealing with types, dealing with the exports on Node, getting the ordering right. Everything else is just a frustrating experience. The one thing I've been most frustrated with in the build ecosystem is when I want to build an NPM package, I need something like rollup usually. But rollup isn't necessarily the best for that last mile compilation. So I have to maintain multiple tool chains, and that's just challenging if you've ever had to do it. So bringing RSlib in would be a nice thing to kind of complete the picture. In other news, we've also got on the federation end, rolling out import map support. I've got PR for ES build support in final stages. We've seen rollup plugin with the new V2 APIs come out, and it's also nearing final support. And for Vite and Rolldown, we've already spoken to the core team, and we'll probably collaborate on integrating it in Rust on Rolldown when it's ready. For this summer, so June, July, we will be releasing V1 of RSPack, which means essentially we are passing 85 to 90% of all of Webpack's unit tests, and that's what we'll call a V1. After V1, there's some cool things happening as well, like import map support built in, multiple output targets, tree-shakeable package builds. In the federation space, we're also looking at something similar to single SPA, if you've heard of single SPA before. So single SPA was really nice because you kind of had that root capability and mount points for different frameworks, different apps. So we're introducing something we've temporarily called like the federation router. But the idea is, imagine if those runtime plugins, when you're importing code, knew about the routing system of your application. So before the app even boots, import already knows what's going on and what's going to happen. And through this mechanism, we can actually mount and run multiple frameworks as one. So let's say you have an Angular app and you have a React app. Usually you have to mount it or do something kind of manual. You can't just import Angular as JSX and it work. But with this, you would be able to do exactly that. If you've got an Angular app, you as a React user or consumer would be importing it just like normal and using JSX just like normal. And this will operate in all the directions. So Vue bindings, React, Angular, and they're all kind of interchangeable. And you wouldn't know that you're not actually using a React component, and it all happens automatically for you. The other really cool thing is there's a routing bridge attached to everything. So you can have your Angular router understand where you are in the React application and take over the routing for the remaining flow if you wanted to. Things like nested routes have been very hard to discover or work with in these kind of dynamic at runtime environments. So with the multi-app router system, most of those issues should be resolved. We are also working on something called RSPack. This one's a little further out, but the idea behind it is we have a lot of native apps in the company, and they're mostly React native. But we ended up writing our own framework rather than using whatever React native things there are. So RSPack is, again, built on the Rust stack, React native meta framework, but instead of using, I think it's called Hermes, the React Native engine. Okay, yeah, I always get the pronunciation wrong. So instead of Hermes, which is quite a large binary payload, the engine that we've designed that runs all of our native apps is about 1/3 of the size, but meets the same performance requirements and all of that of sub 15 millisecond tasks. And then lastly, for Modern.js, we are almost done with it, probably in a week or so. We'll be releasing full SSR support for Modern.js and module federation, along with automatic route discovery. So if you have an app shell, it can just be an empty code base you deploy once every 6 months, and every time a new team adds a new page, adds a new route, it will discover all the routes and stitch the application together for you on the spot. So that kind of covers some of what's coming up. And a lot of the metrics that I kind of showed around the dollar amounts were from what users have reported to us. And what I kind of got from that whole thing is DX makes millions, but DX saves millions, but UX will make billions. And from our calculations and metrics, what we have seen with a conservative estimate, running on this stack with RSPack running the builds and Federation running several other parts, our estimated total cost savings at my company is, again, conservative estimate, hundreds of millions of dollars a year in savings. Yeah. So anyway, that's just a general overview of what we've been working on. There's docs and links to everything, so if you do want to find out more, you can always get me on Twitter, go and read some of the docs. We love connecting with people, helping them out, and hearing cool use cases. So, thank you.
Okay. So, this was amazing, right? Did you enjoy this talk? Come on, some noise. Don't worry, we have to finish this up pretty well. So, Zach, thank you so much for coming here, telling us all about this. This was a really great presentation. Zach will be around, hopefully now. We're going to have our after party. That's starting in around 20 minutes. All you have to do is go upstairs, and then there should be a door outside, still upstairs, where you keep going upstairs. I don't know if it's on the badge. It should be on the badge, but never mind. There's going to be beers, and live music. If you have any questions, Zach will also still be here around, so feel free to reach out to him. I don't have anything else to tell all of you. We had the goodbye session, but the only thing I have to say is thank you so much for being here. Thank you to our volunteers. Thank you to our crew, from staff, from streaming to audio, for making this be an amazing day. Thank you to our speakers, and most of all, thank you to all of you. Thank you for joining. And I'll see you next year.